Alright, I understand.
And Thursday.
Definitely 9 o'clock. So you need to get you before 9 o'clock.
Yes.
I will say that. So from 9 to 11, and then after what you do for the Saturday course, go through the tests. I can't them back to go through, but I mean, do you see? The focus on the whole idea. And remember that assessment is to inform instruction. So I won't be able to see you after to make because what is giving you a test and I can't give you feedback on a test. So I won't be able to see you after, so I need to find something for question.
Yeah. And it's about major errors.
Is this
No, I just want to know.
Oh dear.
Major errors.
Yeah, that's part. Think about what we're doing in the course. That's part of it. To think about conceptual teaching. It's mostly picking up the concept, the idea. So, I mean, I don't know if you miss a lot of the classes, but it's mostly looking at the what's the basic idea behind it. Put that idea to the students and get that understanding, get the understanding. From that, then you build that. You build the algorithm. Yeah. So that's the whole idea. So we look at the CXC syllabus. Look at the errors the students make. Why they make these errors. And what can we do differently to kind of reduce the potential risk of, yeah. Alright. This is what you
I will see what Thursday.
Alright,
Thank
Thursday.
you.
Alright,
Later.
Have a good one.
Yeah, man, you too. Bye. Have a good luck.
Yeah. Actually, no, usually you like go through lunch and then eat 1:30. And then 1:30. So I go from 9 until 8:30 to 11 to bring my 1:30. No, don't bring it. So that's the thing, you should end at 2:30, but because we don't take a lunch break, we take a lunch break at 8. No, not yet. Any luck with the introductory activities so far?
Yeah, I think I have an answer.
You think you have the answer?
Yeah.
All
yeah.
right.
Let me just read the last part. Number 2 of the following restate.
Kezia? Do you have the answer? Yes.
I did trial and error, and I. 1, 2, 3. You didn't say we couldn't use the numbers twice. Hold on, let me try something else. Just saying, only 2 of the following 3 statements are correct, are true. Mr. McCarthy, all 3 statements could be true?
What was the question?
All 3 statements could be, the following statements could
No,
not be
it
true?
says that only two of the following 3 statements about the
Okay.
number. Yes, only two is correct. So is it a square number and a cubic number, and so number 3 is out, or is number can be number 1 and number 3, or it could be any of those combinations, 2 and 3, any of those combinations.
Okay, I got you.
Do you think you have the answer right, Johnson?
No, I got, actually, I got all 3 of them to be true, but you only want two of the answers to be true.
Oh, you got all 3 to be true?
Mm-hmm.
No. Only 2 things. I remember the major thing. It says that the sum, when you add the 6 digits, you should get what? 43.
43.
Did it meet that criteria?
Yes, it did.
Cool.
It's actually less than 500,000. It has cube numbers in it. It has square numbers in it.
Oh, it has cube. That's what you're saying. It has cube numbers.
Like if I cube the number itself.
And a digit. Alright, so Oranges. Let's go. Let's recap. Remember that the digits are different from the number. The number is the entire thing. So you have the digits. The digits make up the number. So you have to start from 0 to 9.
Oh, okay.
Yes, so you have to use those properly. So the digits are from 0 to 9. So if I have the number 43 there, it has 2 digits, and which is 4 and 3. So the digits here, 4 and 3. But the number is 43. So if I have 500, the digit there is 5 and 00. Those are the 3 digits. But the number itself is 500. So the digits are different from the number.
Okay, alright.
Are we clear? So please try to use those properly. Remember that we have to use the math language properly.
Yep, you're right.
Yeah.
I think that I mean, could not be. How is it possible to tell the number? Or instead of receiving?
Tell the number. It says, so you're going to tell the number. What is the number?
43. But the digits. So. Like good. This isn't true.
I don't understand what my students are. Today you guys have a presentation and just don't understand what my students are. Presentation is clear, everybody?
No.
Crystal, are you seeing the introductory activity? Are you able to solve it?
Just got in, I'm sorry. Sorry.
That's fine.
And that's what misinterpretation.
This is square number and it's a
only be 2 out of these 3 that's true. No, only 2 out of the following 3 statements about the number is true. It's the square number. It could either be 1 and 3 or 2 and 2. But when you but the digits itself and you add them up. You add them up, they add up. It's 3 digits. No, sorry, 6 digits. Add them up.
You have the answer?
Add them
Yeah. So is it a square, not the digits, or the square number, but the entire number? So. You know what I meant?
The entire number that we're going to
Yes, it could be a square number. It could be a cubic number. What's a square number? Square numbers are like 4s. Huh? No, a square root of the number. Say the square number, say a specific square number, like 4, 1. So you multiply 1 by 1, I get 1. 2 by 2, you get 4. 3 by 3, 9. So those end numbers that you get, those are the square numbers. So the 3 there would be the roots, but not the square number. Okay? It's not like I was in my yeah. So like 27 is a cubic number. Because if I had a cube root of that, it would be 3. Because you have 3 times 3 times 3, that would give you 22. Yeah. So no, remember that all 3 statements are not correct.
Oh.
It's only 2 of the 3 statements. So it can be like any combination, 1 and 3, 2 and 3, 1 and 2. So you guys, I want to give it to what I supposed to do because I wouldn't be able to figure it out. But. And it has another criteria. When you add these 6 digits, you should get 49. So each of the digits, if you sum them up, you should get 43. Yeah. For me, I would start to say, I would think this is more likely an option. That's what I would start. And trying, because I don't think of a 6-digit number, I think like, this is more a possibility than these 2, because I think that this one, get a cubic number is hard to do. But so these 2 are more likely. That's my opinion.
That's not true.
Huh? That's not true because, again, it's a matter of eliminating. If you have any number friends at all, you should say, you should get that to make a cubic number is that easy. And when I think I can find a cubic root of the whole number, that's not easy. With a square number, it's easier. And this is an easy choice. So if I have this and this and this, it should be okay. No, it's going to take some thinking, but yeah. Okay, Crystal and Arantas, you guys can work together.
All right.
Okay, yeah, you can work together with me. Got it. You're tired. Still up last night at work. So where's Jomo?
Ms. McCarthy,
Yes, sir.
this may be off the topic, but your holiday is what tomorrow? Independence Day?
Yeah.
You don't sound too happy.
What's this we have here? give us back to the
Yeah.
Huh?
Do you guys have a big concert or something on Independence Day?
I guess they'll have something, but nothing that I personally would want to do. So yeah, it's not my taste anyhow.
Oh, okay. All right. Then that. I got it. Let's see this.
What did you do yesterday? What did you do? You said it was a practical. Okay.
No, that's cool. Yes, that's true.
Okay, because I was sorry. Friday? At church?
But cheap, each one is
I went to the match.
Yeah.
I was not sure. No, it's so amazing. Alright, so I'm gonna give you a clue because they're gonna stick. Well, either way, nobody's here to make the presentations. The groups are not here. Crystal, you're working with Arantos in the presentation? Oh?
No, I'm working with Rick, but Rick, I think, is sick.
Yeah, because he is sick yesterday. He didn't look too sharp.
So I have to do it by myself anyway.
Okay. Who is this?
He
What's
doesn't
your
have
name?
a
Adrian, are you there?
Yes, Chris, I'm here. Morning.
Good morning.
Trying to fix my camera.
Okay, cool. Adrian, are you ready to do your presentation?
Yes, is Chris and Tiana there?
I haven't seen her. That's important. I'm just seeing one member. I'm not seeing all the members from the groups. And I would want to start.
Yeah, I could do my presentation.
So you're doing the presentation by yourself. Where's Chrisentiana? You were supposed to be working with her.
Yes, I would rather to wait on her because we were working on a PowerPoint and she has the final of that.
Alright, no problem. Fine. We'll just wait on her. Can you try the introductory activity in the meantime, please?
Okay, sure.
So, Ms. McCarthy, I can do mine by myself. That's why I have to. I said Rick is sick.
Crystal?
I said Rick is sick.
Alright, so you'll do yours on your own. Alright, and let's give the others a few more minutes because you have to do a reflection on this presentation anyhow.
And what I want to do, I have to go first. I just insist on that. I was glad to know.
I'll be able to turn on.
Adrian, can you turn off your microphone for me, please? Thank you. Yes, Chrisentiana? Crystal?
Oh no, I was just saying, I wasn't insisting on going first. I mean, I don't mind, but, you know.
She knows says. No,
I didn't hear that.
So she has it in order.
yeah, she had.
Okay. No problem.
Alright, so some have a book. I'll just take some from there. Can I look for the rest of it?
I didn't do that.
Let's have another spoon one. Let's have a collection, but you keep a collection of them. They'll spoon one each time. So, like you're a 6-month student, but you just probably, because you're working with a lot of time constraint, you could give them and then, you know, they don't start within a certain time they can to go over and dance. Oh God, he was so excited.
And then after I, oh, sorry, I think you did this way. Okay, no problem. But to know that what it was.
Yeah, that's
Yeah, so, well, it wasn't.
What?
And normally challenge him that, normally tell him that, hey, you do not question and he will not get it right. So, but I'm just writing on the board. I mean, just that's all.
the ones who care to do it too, the one who wants to be challenged. So it's a good thing. Because the number skill is so much thinking we have to do to solve it. It's a lot of number skills. So and thinking skills, so when I go to exam, to go into exam that level with that thing, you know, I can think about to get the answer.
Yeah.
When you go to exam, the fight when you go to exam.
Because it will build up confidence.
Or there was something more like that. What did I do wrong?
You don't know what you understand. And I want a example. Formula. Let's say I'm having
Formula for what? It's a factor.
And Mr. McCarthy, you can give us a hint? Say you give us a hint.
Okay, all right. The hint is 1 and 3. Those are the two statements that are correct.
I know that there's a formula for it.
What is this? I can't relate to this. What is this one?
And I want to the pattern, right?
And sum up. So what is this going to? It's divided by this?
Oh, this is
Oh!
the original question.
What's that original?
And then I'll say this is the one. These are the same.
I'm not following you. I have an in here and sum up and
I'm summing this. So this is original.
what's the question asked?
What is the formula to add up? How would I do the sum of words? By and
I just probably to see the question and understand what to say. So this is the first number in particular.
but we're adding.
Yeah. So because the formula is formula, so this is what you will do. This next thing.
Yeah, what
For the first 6.
I want a general formula so that I can know what the sum of is. Is that 1,800.
And that's how you got it.
Do you remember these things? Here.
Alright.
Alright, so I'm going to calculate for the result. I can check it. No?
No, good one.
Go ahead, do your thing.
Yeah.
I'm not gonna get it. You're right.
Adrian,
We get on.
Yes, miss.
how far are you?
Need some more time, miss.
Like how much more? 5 minutes?
Give me 5 more minutes.
Alright, that's it. I can't give any more time.
It's a square, it's a not square.
So I need 2, 4, 4 rings.
Did she say she got her thing?
4.
R. Silver.
Yeah.
Yeah.
This was.
Oh. You made changes. I thought you were making changes.
If you can see the things
Yeah.
that I added my arrow. On there. And I knew it.
But that's the format I picked had the titles at the bottom.
Right, so I just moved this one.
Oh, you moved all of them down.
No, just made the titles.
No, I was saying, oh, the titles.
Yes.
Yeah.
I got you.
And 9. And 8.
And then seven and 8.
7, 7, and 16.
This one, the Aries.
Oh,
And 9.
So let's give it again.
No, we had Jomo. It is great for.
That's a view.
No, that's not Jomo. No, that's not all Jomo.
so she can hold. Question given.
I'll see Jomo.
I wasn't sure.
9. 5,
I must see you, but I'm saying that. Alright, let's go.
Is it a minus number in this? Can it be a minus?
No.
It's 6-digit number.
I don't know how you got 43.
Hold on a second, miss. 1 more minute.
Alright, Adrian. Go, Adrian.
7, 8. 24.
So remember the clue?
43.
Oh, I think I have it.
1, 2, 3.
Really? What do you call? What?
That number.
3, 4, 5.
0.
Yeah, that's the numbers. 1, 2, 3, 4, 5, 6.
Oh, I think I have the numbers.
No. It says it's on the numbers. It's on the bottom of the bar.
Oh, gee.
That's 900.
0. It doesn't work. Oh, it's numbers, and then I need to break this number up. That's 3 and 4. 4. 4. I think I have it.
Really?
9.
Alright, tell me what you have, Mister.
No, I don't have it. I give up.
Let me see. You might be right.
Where's an Adrian? Adrian is close to cracking it.
I missed the number. I missed the 8.
You could make that a number. I think I know the numbers that you have to include, but I don't know how to.
Come, Adrian, we're all depending on you.
489,994.
I'm applying lots of pressure now, Adrian.
Come in, miss. Come in. Give me one.
Go ahead, do that.
You said 8?
489.
I did 49994. That's 35. So plus 8.
And it's no 4.
43.
I think I got it, but I don't know how much. It's a square.
Ready, miss?
This
I
Adrian,
think I have it.
what do you have, Adrian?
5.
It's 499561.
Alright, let me check that.
I have another number. I don't know if it's right.
499.
561.
No, I have this. So, can check those two to see which one we have.
Well, I had the same number, but put in a different order.
What did it? What
Miss
what did
McCarthy,
Yes, Crystal.
It should be in a different order.
I had the same
Numbers,
number,
but in
I
different order.
just used them in different orders. You said it's got to be squared, no? So how is it a 9 on them? It can be 9 to be squared. Oh, right. So she did 489,994.
You add these numbers. Do you get 43? Is this number a square number? And is it under this number?
Yeah, 489994.
It's not a complete square.
It's not a square number.
I think it's 600.
Find the square number.
Yes, please.
It works in fact.
Yes, it works.
So what's the square root? When you find the square root of this number, what did you get?
707.
707.
Yeah.
So it's number 1. The number is under 500,000, right?
500,000.
When we add them, let's add them. 4 plus 9 plus 9 plus 8 plus 4 plus 9. When you add all the digits, what did you get?
43.
Alright, so this is it. Did you work for this one? Can you test that one? You get it now?
Hold it, all right.
It can't be a 5 is 6 to be. It's 11. 11, 12, 18, 10, 21, that's too many. That's 9, 30, 34. That's too little. That doesn't add up.
Alright, this doesn't add up. It's very close. Very good. Good job. And Crystal, I think you were very close also. Good job.
Thanks.
Yeah, your numbers are
I think yeah.
Don't do it again. Okay, thanks.
Then when somebody goes to this month, he said the boys have come to you free of charge. What's that? I'm taking they don't fit the can speak. I said, well, he's got one more. So he said, okay, well, send it. I said, and it's pretty much.
No. So Crystal, do you want to start?
Oh, huh? Sorry. Oh, you can start already. Ready, my pencil? Do you want me to start really good? I guess so, Miss McCarthy. I really didn't want to start, but I'll start. Does it mean you're going to chew into me first?
I didn't hear you, Crystal.
I said, are you going to chew into me first? Are you going to be nice if I go first? I'll go first.
I can't make any promises.
I thought you said you're going to tell us about our syllabus first, and then we do the presentation.
Reminded me. So, Arantas and Crystal sent me a copy of their syllabus, the Cambridge syllabus. But one thing I noticed, Arantas, I don't think was very good, is that when you look at the CXC syllabus, Arantas, when we look at the CXC syllabus for probably a lot of the things that you have to cover in the Cambridge is the same thing that we need to cover in the CXC. Yeah. Would you agree with that?
Yes.
Yes?
Yes.
I know that the syllabus is kind of missing some things, that the purpose is needed, the purpose, the methodology, resources, all of that is missing from the syllabus. So it's very vague.
Yeah.
However, you should be able to read the objective. And I don't see the objectives are very specific either, but that's what you gave me. That's my thinking on the whole thing. And the one thing I also noticed that it was very spiral. So for like stage, I think it was stage 7. You had a stage 7 and a stage 8.
Right.
Yes, so for the stage 7, like it's just like ours. So you'll start like algebra, you do the basic in algebra, then for stage 8 you'll pick up from where you left off. So it's very spiral too, but it's the same topics, the measurement, the algebra, it's the same thing that we would normally do in the C-set paper. Okay. So a lot of the objectives are common, are similar.
Okay.
Yeah. But if you look back at the list of things that I gave you, that should be in our syllabus. You realize that there's a lot of things that are missing. Okay?
All right.
Okay, Miss McCarthy, I'll go first.
What was that, Crystal?
I said I'll go first.
You go first. So did you send the PowerPoint presentation?
Yes, I sent it to you this morning.
I need
Ready
to
to
bring it up.
I'm sorry.
She said she's gonna bring it up. Yeah, you have to look up your app and you already done it, so you can't think. You already did. You should be able to.
Hey, you don't need this for the internet.
Maybe I should just use this computer.
Good morning, Miss McCarthy. Good morning, everyone.
Good morning, Chrissy.
Good morning, Chris.
Excuse me, I need to get on the computer, but I'm not getting on. But I need to get on the system, but I'm not getting on. I don't know if you can. Yeah.
You're not logging in?
Yeah.
You'll see your opinion for this one.
I didn't do the eligible because the app was actually not involved.
Because it's
If it's you want to have some.
should they, yes, I don't need to pull up something here. Just a idea.
I don't know if I did this one. I just do it.
Which one you did, Kate or the CX?
I did that all of them. And it's a time constraint. I think the one that was the it's free.
She's right. She actually, her one did not have very good matrices. She didn't want bitches kind of but in the other one, the CX, that had like barely like I can see maybe 2010. As they got farther on in the years, they started to the comments started to diminish a bit. So they had it for 2010.
Oh, yeah. Buy stocks in Hammerville and wants to join because I've read some newspaper.
I'm saying, this is so low. So you heard something.
Well, they must make one. They can make a lot of money off of me.
Alright, so we're ready now. Crystal, you're going first?
Yeah, I'll go first since it's hard.
You may go first. You may go ahead. Alright.
Just a second. Just a second. Ms. McCall.
What do you want? Do you want the? Can we all see the screen?
No.
No. Can I call you right back to my person before? And I can speak later and I can do something about it by the end of today.
You're trying to do
Okay, I'll post after that. Okay.
Something about blanks. Are you seeing it now, Crystal?
Yes, thank you. Yeah.
I saw it put on the
Okay, do you want me to start now?
okay, let me just slideshow.
Okay.
Alright, so no more kids need to operate the computer. No more.
That's how she got it here. Oh, and she did. She got it. Everything. Yeah.
Crystal,
Yeah?
did
Can I
we
start?
work on this PowerPoint with you?
You want the truth? No, he didn't. Well, he was supposed to, but he wasn't feeling well yesterday, so I haven't heard from him.
Okay.
Yeah, it's no evidence of teamwork. I do have evidence of teamwork. I put good.
Okay, good one.
He gave me, we went over and did endpoint, but in terms of putting all together, because he wasn't feeling well, I kind of did it myself. So we did go over the questions together.
Okay. Are you sure about that?
Yeah, we did it.
Yeah, we did it in class yesterday. Everybody did theirs in class yesterday.
My colleagues took votes for that. We went through Kate, which was easy because Kate really didn't have statistics. Shall I start, Ms. McCarthy, or? I'm sorry?
Is the first presentation, sorry.
Yes, you were saying something to Santana?
I was just asking if that's the first one for the day.
This is the first
Yeah.
one. We're
Oh,
waiting
yeah.
on you to go first.
Chris Santiano, you want to go first? Really? You can go.
What?
Just messing with you.
Okay, I'll do it. Okay, I'll do it. Okay. We have to present on statistical errors that are found in the CAPE as well as the CSEC examinations. So it was 4 areas, distinct areas that we were to look at, which dealt with frequency table, bar chart, histogram, and the cumulative frequency curve. And the first one stay right there. With the frequency table, we actually found, looking at the reports that were given, it looked like the students actually had a good grasp on how to complete of the frequency table. So there wasn't any errors that were reported. Most of them, in more than, I think actually all of the reports, it said that the students showed a significant understanding of how to complete it, and they actually completed it correctly. So we didn't find any errors specifically in how they completed the frequency table. On the next slide, I actually combined the bar chart and the histogram, and it said on 2 exams under the CSSE for January 2012 and January 2013, It said that students were unfamiliar with the term model class and proceeded in many incidents to state the highest frequency outside of the interval. What I gather from the students being confused with, when you deal with frequency, it's important to understand that it's different than a bar chart than what you would see in terms of a histogram, because usually when you do with frequency, they present it in a histogram. And in making the note of the difference between, the students didn't understand that they should have looked for a range instead of, because with the histogram, you're looking at the cumulative or the continuous data versus a bar chart, which actually separates it out. It's not cumulative, it's actually set in categories. I think I can better explain if you can go to the next slide, where I actually did a diagram of the histogram.
Crystal?
Yes?
Can I ask you to pause a minute, please? Miss, I'm not seeing the image.
Oh, yeah, you're not, sorry.
The screen?
Yeah.
Okay, I'm seeing it now. All right, thank you.
I think what the problem is, Adrian, is once Crystal is speaking, then you won't be able to see the screen.
Yeah, but McCarthy, remember once I think there was, I'm not sure if it was your class, but remember there was this thing where I think they call it sharing the screen, where all we would see was the slides. Is that possible today?
Can we do that? Anybody?
Because I don't think it is that important for us to see her. I don't know if we can see the slides, so we can share the screen.
I understand what you're saying, but I'm waiting for somebody to come back. I don't have any laptops here.
Okay. Because we can't follow.
If I put my PowerPoint, can you see my PowerPoint for Santiana? Well, temporary.
As long as you, oh, okay. All right.
All right.
Is that fine?
Can we share the screen? Yes, we're doing that.
Yeah. Is that easier?
It's not recording. It's recording, but what is happening is that once a student is talking, they won't be able to see PowerPoint. So we did that thing that we call share the screen, where even though the student is talking, they're still able to see the screen at the same time. Do you know what to do? I don't think I do. Can you call Craig? Yeah, we're seeing it, but once
Mr. Fonte, you can do this.
Alright, no problem, let's go.
Ask if they're seeing it.
Chris, are you all seeing the screen now, Adrian?
Yes.
Alright,
but I'm when she's speaking.
Once he starts talking,
gets lost.
It's going to be cheap. Now, I mean, for her, she has her printout, so that's going to be fine. But what about when we're about to present? I mean, I don't know if we can get it first. I don't know.
So what happens with it instead of recording?
Yeah. Well, by the time you come, Christiana,
What's
we
that?
should get a technical person to fix it by then.
We probably just have to go to the other take it off recording. That's probably what it is.
I'm not hearing you clearly.
I said we probably have to take it off recording. Just put it on a regular line. That might be the issue. I'm not sure.
Will a tech person be back in shortly, Ms. McCarthy?
Yes.
Okay, so then we can let's continue and then we'll fix it once the person comes.
Alright, okay, go ahead. On his way. He's on his way now, yes.
Okay. So what I was saying was in looking at, they didn't understand what happened with the students was they didn't understand that with a histogram, you actually look at the interval, meaning you're looking at a set of numbers between 1 and 3, 4 and 5. That's how the interval, because you always have it where the numbers are always cumulative. Basically where they are, it's a continuation, where you see on this chart here, where the numbers are actually in a range from like 100 to 400. So it's a cumulative thing versus a bar chart where they're set up in categories. So I think what they did was they were not thinking of a histogram where they're thinking of numbers as cumulative, so they didn't give the interval numbers. They basically gave a single digit because they were considering to be similar to that of a bar chart. So that's that's why I think they came to an error.
Okay.
The next has to deal with the frequency curve, and I actually saw that there were a number of errors to do with the frequency curve. The first one was that they failed to draw the cumulative frequency curve using the cumulative frequency as they used the frequency. They used the actual frequency values instead to produce a smooth curve. My analogy of this was that students had not equated that when you plot a cumulative frequency, you should have an O-gives curve should be constructed instead of the smooth curve, which, because they plotted the smooth curve, that indicated to me that they actually did a frequency polygon, which is derived when you actually plot the frequency curves. I think if you can go on the next slide, I'm sorry. If they had understood in their mind when the question posed that it has to be a cumulative frequency, they would know that it should have actually looked like this is actually a O-gives curve where it has that at shape versus the frequency polygon, which tends to go up and down like a hill. I think if they had understood that actual concept of the shape that is actually given when you do cumulative frequencies, they would have picked up on the error that they were actually plotting the wrong curve, because a lot of them gave a smooth curve versus the at-shaped curve. Another error that I saw was that another error that was common on the frequency curve is that they interchanged the axis when they were plotting the points. And from this, I concurred that the students did not conclude that the cumulative frequencies is always plotted on the vertical axis because it's the dependent variable. And I don't know if you remember, meaning that it relies, is not independent, so basically it relies on something in order to make it move. The next one that I had to do with another frequency error. They said they were unable to use the cumulative frequency curve to estimate the median. The students, from this I gathered that the students were unable to subdivide the curves in the various quartiles and determine the median value on the curve. Because had they been familiar, yeah, sorry. Had they been familiarized with how to construct the median in terms of splitting up? Basically, what they were doing is they were looking at the numbers instead of using the actual curve, the Ogilvy curves. So it's actually you construct, instead of using the curve, they were basically looking at the table and extracting the information from there. What they were supposed to do was to break each of them up into a lower quartile and an upper quartile, and then formalize the median, which is the difference of the two, in order to get the median. Because they misunderstood how to break up their quartiles, they weren't able to answer the question correctly and demonstrated on the well, basically, they weren't able to demonstrate it on the curve. And the last one, again, it was another frequency curve issue. It said that it used the lower limits and the midpoints instead of the upper class boundaries. And like I said, with cumulative data, because when you plot cumulative data, is a reflective of like a continuous data set. And because of that, you run the risk of if you don't set boundaries, well, let me read it correctly. I said students did not correlate, or did correlate, that because they were asked to plot a cumulative frequency, they needed to set boundaries. They didn't know how to set the boundaries, so they tended to use the midpoints, I think they also use frequency, lower limit, sorry. What they should have done was understand the use of the upper boundary limits, which basically looks at the midway point of each interval, and then you get it from there. What they did was, I think they understood the concept, but they didn't understand how to get the boundary. So that's where they got into that error. Instead of they never thought to use the upper class boundaries. And that was it.
Crystal?
Yes?
I don't think that I am satisfied with the cause you gave, because remember, this assignment is geared out looking at the errors and what that's the main thing, and what might have caused these errors. I see the errors and you've outlined the errors, but I'm not seeing like you're giving me an in-depth report or review or something to tell me that, okay, these are the possibilities, these are the possible things that might have caused. You do mention it, but it's not very detailed. Am I making sense to you? Okay. It's not detailed. It's not detailed. Can you add some?
It was too surface now.
Yes, so even though you might mention it, I mean, when you look at an error, there are several possibilities why a student might make these errors. It might not be just one reason why a student make an error like this. Right. So you have to look at different possibilities. I'm not seeing that in your presentation. Can you do anything? Can you add anything to your presentation at the end and give you a chance to?
Yeah, I can do that. I don't have my laptop, but I'll try. Yeah, I can add to it.
I'll ask you to give me some more reason why students made these possible errors, okay?
That's fine, yeah.
Right. Alright, who wants to go next?
We'll go next because we have a PowerPoint presentation.
Who will go next? Who will go next?
Christina and Everett.
The one next, what time did you say?
You did say one.
I said, you said.
You said one?
except when the first time with me and Cobra. You know what I'm saying?
I coded, Christina Morantes, so.
But you
Christina, are you
just,
hearing me?
Yes. We're doing the one from me.
What was that, Christina?
We're doing the copy from me that was emailed from my email address.
Oh, so you want me to bring up that presentation for you?
Yes.
Okay.
The
John, will you have a PowerPoint? That's yours, Rosina and Andros. That's your
yes,
presentation?
ma'am.
Okay, so let me give you that.
Ms. McCarthy, can I ask you a quick question?
Sure.
Do you want this before the end of the class, or when do you want me to resubmit this?
Okay, I would want it by the end of this class because from what you gave me, remember, from what you gave me, you need to give me a little bit more detail. You're not giving me enough to give you a grade for that section. Are you clear? Crystal.
Yeah, I'm sorry. I'm sorry. So,
You're not giving me enough, so I can't give you more time.
That's no. I understand that.
I don't have another day.
No, I understand you. I was just trying to see whether or not I'm going to give Rick a call because I wanted Rick also to include his examples. But if that's the case, I'll sit here and do it myself.
All right, you guys may begin.
Okay. Just one question. Does anybody have an electronic device in the class? Like an iPhone or something?
Do you guys have an iPhone or something?
Something of the sort. iPhones, except for Miss McCarthy. Was one iPhone for Christmas birthday last year. Oh, the record though. Oh, the record. Sorry, recording. Randos?
Yeah.
Oh, you hearing?
Yeah, I hear you. Somebody has an iPhone?
Oh, no iPhones. Miss McCarthy left hers at home.
Miss McCarthy?
You guys have Androids?
Miss Antenna, you were saying something?
No, I was just asking if the person to do the sharing of the screen is there yet.
Not yet.
Okay.
Okay. Miss McCarthy?
Arantos, is there something else we can do to help you in your with the presentation?
No, what I'll probably do is I'll see how I can work it in. I was just thought everybody would have had an iPhone or electronic device, but it's fine. I'll see how I can work it in.
Perhaps the PowerPoint, we could look at it, you could bring it up and we look at it?
Mayor Pardon? I didn't hear you. Sorry, Ms. McCarthy.
I'm saying, we would love to look at what you want to show us. So I'm asking you if you have it in a PowerPoint or something, if you have it in a PowerPoint or a link or something that we could
No,
just...
I actually had an actual tablet itself, but I didn't put it on the PowerPoint. No. No.
So how would we be able to follow?
No, this is an actual app. It's an app on iPhone. So I was going to say, like, in order for them to solve the issues, the app itself could have broken down the actual matrix as slow as possible. So we can just yeah. All right. Yeah, I'll put it. Mr. McCarthy, what I can do is, I can show the actual app when I get to certain areas, to show how really the areas that I found in the CSDC, and I'll do it afterwards because we're going to go through the areas of both the Cape and the CSDC, and then myself and Rosina will explain pretty much we found the same thinking process between the students. So I just figured out that the app that I found, sometimes if you are tech savvy, teachers may be able to use this particular tool in class and show it to the students, and it will slow it down for them so they can see where they actually are wrong and where they can correct it.
All right, but Oranges, we're not seeing your face.
Oh, you're not? I'm sorry, too close. I'll sit down. That's fine? Right there, that's fine?
Yeah, that's better.
Okay. As you know, myself and Rosina did the CSC and the Cape. I actually did the CXC first. So you go to the next slide. I did it by year, and it
what
shows.
What topic are you doing? What's the topic you're doing? What's the topic?
Oh, sorry. My topic is matrices. I'm sorry. My topic is matrices. Okay. And I found that in each year, some of the errors were similar, and some of the errors started to a little bit fade out. So in the year that they did it in, I think 2010, is significant. Huh? That's right.
Yeah, Ms. McCarthy, did you get that from my email or from Aranta's email?
I got it from Aranta's email.
You need to do the one from my email.
Yeah, from Rosina's email.
Because he's got the titles down the bottom.
It's just the format. She switched the format. That's all. I had a different format from her. That's all it was. And she made some changes. Okay, that's the one. That's the one right there. Okay.
No, she says that. Okay, we're ready to go now.
Sorry. All right. As the CXC was actually self-explanatory, it actually broke down where the students went wrong, the errors and what had happened. And at the end, I would explain. Because Rosina and I just pretty much sat down and said that the same issues that the process of the thinking on the Cape and the CXC were the same. So we'll probably just go through the errors first, and then at the end we'll go through the process of the thinking. That's fine, Mr. McCarthy?
Yes, it's your presentation.
All right. First year, I guess, assuming the first year they did the matrices, which is what we're doing. A significant number of candidates were unable to correctly multiply matrices. I'm not sure. I'm sorry, I shouldn't say I'm not sure, but I would elaborate on that further. A large number, also in 2010, a large number of candidates did not recognize the inverse of the matrix B was initially the matrix A. So they didn't realize that one matrix was the inverse of the other. And also in 2010, candidates did not use inverse obtained in part 2 to solve X and Y parts. That means several candidates had problems inspection. Many of the candidates did not correctly or correct order of performance matrix multiplication. So that actually occurred again in 2011, which they had the same issue in 2010. They failed to connect the two parts. So we see a pattern of multiplication and connecting the actual parts. And candidates encounter difficulty defining the inverses of a 2x2 matrix. So basically, each year following that, similar situations come up. 2010 and 11, it was pretty much multiplying. And also 11 and 13, sorry, 10 and 13, inverses kept popping up.
I am very sorry to disturb. Miss McCarthy, I find it very unfair that the students go through the stress of preparing a PowerPoint and I don't get to see it while he's talking, so it's hard to follow because I am very visual and I want to see so that I can understand what he's saying, although he's explaining very well, but it's a bit hard to follow. So I don't know if you could send the PowerPoint to us and then we follow it on our computer. So I see.
Alright, so that's an option. I'll just send it to everybody now, okay?
Okay, please, thank you. Sorry,
No problem, Chris. I have to present the answer.
I would say I sent ours as well, just send both of them saved.
I need to close this in the meantime. I need to save it first. I'm just going to download all the PowerPoint. So as I have them on stuff. Just wait.
Yeah. Sure. Yeah. Just one.
So, I'm sorry. This is stupid.
Because it's already in the alone. All right, you all should have that PowerPoint now. So Tina, are you seeing that, Adrian? I sent the PowerPoint.
Yes.
looking for it.
Did you find it?
Not yet.
She can check for me. Is it just
Right.
You got it, Chris?
I gotta find it. That's it. Refresh the page. Yeah, that's
Chris Santiana, you got it yet or no?
Yeah, I just got it. Thanks.
Alright, no problem.
So when we're ready, I can just send them out to the
Yeah, difference between Q and
It's not in the.
Southbound. DCX. Right. Her, Kate wasn't, didn't say specifically. She had. Right. Mine has more.
But no, this. You need to compare.
But see, this is why I need that, so I can give an idea of like how my mind should be slow speed down. Okay, this is what they do. So if you show this, unfortunately I have, but I could probably try to show it to the camera. This one, as I can. But then I'll be able to student in the time. I just wrote down reasoning outside. And it could be another reason why they didn't perform.
Right, that's what students and students.
Right.
How come I feel? I don't understand. I didn't get a sample too. Your jazz one. It was the same. I don't know that thing.
You did?
I did. I
No, she said many words. She said I was back to it. Percent, yeah? Yeah, she's got it. I asked her. She's got it. All right. Adrian,
Yes.
you got our copy of PowerPoint?
Yeah, I got the PowerPoint.
All right.
Okay.
Good.
What I did, I went ahead and I sent all the PowerPoint, so you should get that in your email so you're able to follow. Okay?
Yes, ma'am.
Yeah, thanks,
very
miss.
much.
All right. All right. Sorry, apologize, Rantos.
That's no problem, Ms. McCarthy. I mean, you know, we had issues yesterday about that. Trust me, it's no problem. Now, these are the I would consider, from my observation of the CXE or the exam that you guys did, these are I would consider these serious issues for the matrix part. Or Zena's going to explain the CAPE part. That'll be the next slide.
Okay, so all right, so the common error was, it was only one that I was able to locate on the CAPE, and that was in the 2011 exam. And the report mentioned that this candidate used the algorithm approach to answering questions, and they showed no evidence of using the properties of matrix to obtain their answers. So you go to the next screen, and I just did an example of a problem. So, for instance, if they were given a question like this, a local shop sells, and I used this because it was a simple question, and also, or it's a simple example, and also it would have appeared under their matrix title. So they have actually the title written on the exam, and it says that these questions have to do with matrices, counting, and complex numbers. So the students had an idea that they should have been probably using matrices. But in answering a question like this, for instance, a local shop sells 3 types of pies, and the 3 types of pies are chicken, beef, and vegetable, each at different prices. And you go to the next page, they sell these pies for a period. They wanted to find out how much pies they sold in any particular day, what was the value of it. So we go to the next slide, and they were asked to show their working. So in showing their working, they used the algorithm approach. So the next slide, they used the algorithm approach, and so they probably just took the 13, the quantity of 13 in the for the beef pies, and times all of the amounts for the beef pies times the $3, and all the amounts for the chicken pies times the $4, and all of the vegetable sales times the $2. So to get their answer. So not demonstrating any form of matrices, but if they would have used the matrix method, which is the next slide, they would have had established in the workings, they would have established a first matrix of 1 by 3, and then they would have had a second matrix of 3 by 4, demonstrating that they understand how matrices work, and then showing they could have put the arrows at their showing how they came up with the first answer. That's how they calculated all the following answers. But also they could have demonstrated to the person that was marking that they understand matrices by demonstrating that they, showed that they multiplied each number by its relevant total of pies sold. So putting it in a matrix showed that they can take information that's an everyday situation and put it into a matrix sort of formula or from that approach. But most students or candidates showed no evidence of this. They did it mostly using the algorithm, which is just basically how we were taught to calculate the value. Okay, so that's the big problem. So I kind of gave a demonstration of how they showed no evidence. This is what they were expecting to see, or some form of this. Okay, so the next slide is going to go into what was the candidate's thinking behind the errors.
Rosina and I can't, well, when we went through our separate reports, most of our thought process was pretty much the same. Like the specific, the questions didn't specify that the problem was taken from the matrix approach. So like you said, the algorithm, they just went in there and did the algorithm problems. The candidates had a preference of algorithm approach and dot products, meaning when you put 2 times a number, you gotta put 2 dot times 2, or they just look at it as an algorithm, not as a matrix. The candidates may not see the necessity to solve the problem this way because they didn't understand it. Maybe it's a typo in the fourth one down. It should say the candidates not know how to interpret the question given, not who. It should say how, and that's what ended on given. They probably looked at it and didn't understand how to interpret the question. Maybe they didn't learn the prerequisites of the matrix, of how a matrix works. Typically on exams, students or candidates could have been nervous, unsure of their own ability to solve the problem.
Give me an example. So, okay, I need to stop you right here. So I get, so so far, you have the errors, and now you're thinking that the students thinking behind this error, which is a good thing. But can you give me an example per se? Let's say the question is specify the problem, and the problem was taken from a matrix approach.
Right.
So that example was because under the titles in their exam, it actually says that it's counting matrices and complex numbers. So that's how I came. That's how I came up with that first error or their thought behind it, because they never looked at the question. Like it falls under matrices. It's not algorithms or any other section. So they should have took the time out to. Oh, I'm sorry. In this particular one, sorry. The first one, they didn't say, like, because it was under matrices, I guess the candidate was expecting, I'm thinking the candidate was expecting to say matrices, you know, how note that is a matrix question.
But Rosina, should it matter? Should it
No,
matter?
Right, but that's why I was saying that's probably why the candidate made the error, because they didn't. That's my goal.
But is that an error? Alright, so you look at the one that you have for 2. So the candidate had a preference for algorithm approach, the dot product approach, not compatible with using matrix. I don't see a problem with that. The idea of in a math class is to get students to solve problems using whether alternative algorithms or not. That's not, for me, is that an error. So you said the candidate did not know how to interpret a given question. Okay, that's a fair, reasonable thinking. However, give me an example of a situation like this that you observed. I think that it applies here. Give me an example.
Okay, I actually have one of the questions that we got off of the CEO. I got from Weebly. I guess it's one of you guys' tutor sites. It says the matrix J equals 0, -1, 1, and 0 represent a single transformation. Now, possibly they don't know what a transformation is, so they just probably went in and just did the actual problem. Let me just see what's happening. So okay. Let me try to matrix. Here's, I don't know if you'll probably be able to see this, Ms. McCarthy. It says a transformation, and then it says, the other problem says the image of the point P, transformation J, is 5, 4. Determine the coordinates of P. So they probably just thought that, okay, if J is 5, 4, then P may be just another coordinate, not knowing that it should have been done in a matrix or transformation form. So if I can find I don't know if you'll be able to see this, what I'm doing. Determinants and inverses. Now I have here an actual app on I don't know if you guys can see this. It might not be clear. It's an app on this is an iPad. On an iPad, and we downloaded just to test out matrices and whatnot. And to let's say, and it would actually go through the actual matrix for you. Let's see. Now, in the question that was given, and I'm just giving an example. Let's say they didn't know how to add matrices in an example. Let's see if this works. Hopefully, you guys can see it. Now, it would say play the solution. Now, it will play the solution for you slowly, and it will give the student. I don't know if you can see. Can you see that or no?
Yes, we're seeing it. We're seeing it.
Now it will go very slow for you and give you examples of what should be right, and the student will say, okay, I went wrong in this area. That's addition, and they can go back and do multiplication, inverses, determinants. So if
all right, so what's the name of that?
The app is, what's the name of the app itself?
Yeah.
It's called hold up for a second. FX Map Solver.
What is that?
FX Map Solver.
Map Solver.
Yes.
FX.
Map Solver. I have it on my pen. I was just using crystals on my iPad. Let me see if I can. And it should have an icon like, I don't know if you guys can see that. It should have F equals a question mark. Now, if you actually download the actual app, it will take you through, you can slow it down, so it will go real fast, but you can slow the actual app down to show how to work out problems, the inverses, the determinants, and pretty much even the transverses. And it will slow it down for you, and the students or the candidates, if you're in class using that type of technology, you can go through it with them and let them see the issues that they're having. Instead of, when they ask a particular question, let them know this is the inverse. This is how you find the determinant. This is how you will find the evaluation. This is how you will do operations of a matrix. So they understand the words and the terminology, so when they go into the exam, okay, they ask me for a transverse. They ask me for the inverse. I know what those type of words mean. I can actually see how to work it out step by step. And I believe if you show these students that sort of methodology, using terminologies like that, with technology, they may be able to get through this matrix a little bit easier. Are you downloading it now or no?
We're fine, I'm fine.
Okay. Any other questions? Or
I have no more questions. I don't know if anybody else has.
no other questions? Hello?
All right.
No questions.
No questions.
All right, that's it.
I
Thank
would
you.
prefer everybody to have like an electronic device. It would have been easier that way. But we didn't specify that everybody should have one.
All right, thank you, Rosina and Arantas.
Adrian, do you want to go now?
Yeah. Hello?
So we have an Adrian and Crescentiana.
Okay.
Miss, I can get like 2 minutes just to adjust the Wi-Fi outside.
All right, no problem.
Okay, did everyone get the PowerPoint, our PowerPoint presentation?
Yes, Chris.
All right, Arantas
Yes,
and
ma'am.
Rosina, did Arantas help with the assignment?
Pardon?
Did Arantas help with the assignment?
Did I help
Did
you?
It was equally done.
Speak now or forever hold your peace.
Hey, you're trying, Miss McCarthy, you're trying to start a divorce school up in this camp.
No. Arantas, did Rosina help with the assignment?
Of course.
All right.
It's not 50-50, it's 100 each way.
Chico. Agent, Crescentiana,
Yeah?
did you send a PowerPoint or a Word document?
No, I sent both to you. To you, I sent a Word and a PowerPoint, and to everybody else, I sent just the PowerPoint.
All right.
Okay, I'm back.
Okay, so can we begin?
Yeah, sure.
Miss McCarthy? Can we begin?
Alright, let's go. Are we ready now?
Okay, good day everyone.
There.
Myself and Adrian, we're presenting on vectors and trying to understand students' common errors in the CSEC and CAPE exams. So we started off with CSEC, May or June 2010. And what the question required the students to do first off was to actually plot the point and they had to copy the diagram and plot the point. And also, after writing some expressions to represent certain vectors, they also had to write a short description for geometric relationships. So we can go to the next slide, which discusses our errors. First off, it was recognized that the students were unable to place M and M correctly. And this is more evident because of the students' lack of fractions. Students just see fractions as maybe just an entity. They don't have an idea of how to link it with real life. So when asked to place M on 1/3 of JK, they place it randomly, the same for N. So they lack the understanding of fractions, and it is affecting their vector representation. Next slide also says that when attempting to state the roots, negative signs were omitted. So in the question, when they're asking, if you ask for a certain path, they omit, if you look at you going forward as positive, and if you're going to use a negative, the students are, they're not. So the use of integers, when to use the positive, when to use the negative, it is affecting the vector question. For the next slide as well, students had difficulty setting relationships between MN and KL. This showed that students have a poor mathematical communication skill and they lack of because if they had that practice in communicating mathematically, they would be able to give one or two sentences about their relationship between two lines or two vectors. So it is because of probably their confidence, or they don't have the practice of writing descriptions on geometric relationships between vectors, and so this was clearly shown in the question in 2010. So we're going to 2011, and I will pass on to Adrian.
Okay, thank you, Chris. Okay, morning again, guys. Okay, now let's look at 2011. Looking at the question, we can actually consider the requirements of the question. You know that for this particular question, students are required to combine vector quantities, and also use vectors to solve geometrical problems. Go to the next slide for me, please. Okay, for this question, the mean mark was 1.93 out of 15, right? This is somewhat adjusted. It's not reflecting the vector question in essence. If you should look at the question, we just highlighted the vector portion of the question, but it's actually a question inclusive of vectors and matrices. Now that is marked out of 15 and the mean mark is 1.93 out of 15. The vector portion, however, consisted of 8 marks. So if you do that on average, students would have actually scored 1.03 out of 8 marks, which is really unsatisfactory, right? Now, when you look at the errors or the possible reasons for the errors or the insights into students' thinking, first thing you will realize that is based on the requirements and the performance of the students did not have sufficient prerequisite knowledge to complete this question satisfactorily. One major point here is that students found it difficult to construct algebraic expressions to represent vector quantities, right? So in terms of their capabilities in relation to algebra, it was very lacking in this department. You will realize that in terms of the language used, for example, when students are asked to express a vector quantity in terms of A and B, students did not understand. As opposed to when they follow the textbook question where you will ask students to write simple algebraic expressions, even though they will be able to do that, the problem lies where you ask them in terms of a quantity, or if you ask them to transpose a particular quantity, then they will have problems. So students didn't relate very well to that aspect of the question, right? It was also evident that students lacked conceptual understanding of the topic area. They were not able to associate vectors with, say, for example, coordinate geometry, and so their approach to problem solving was very limited. So they had very little avenue to which they could manipulate their thinking to solve the question. So they had very little conceptual understanding, and as a result, they could not derive the resultant vector or even sketch diagrams or trace the movement of a vector quantity associated with a negative or a positive value in terms of its direction. Also, they displayed very limited vocabulary knowledge, right? They were not able to interpret the question properly because they did not know the meaning of terms such as collinear and, say, for example, midpoint. So this was a major problem for this question as well.
Okay, so we can move to 2012. And if you look at the question actually required the students to combine vectors to determine resultants and also to state, again, the geometrical relationship between two vectors. They also had to sketch the relative position of given points. For students, it was obvious that students had difficulty describing the geometrical relationship and representing the points to show their relative position. And if we look at just the portion, the vector portion of the question, 1.5 out of 7, okay, the mean mark was 1.5 out of 7 marks in total. And so students seem to be having a problem with geometry and plotting points to show vectors. Moreover, again, I have to reiterate that students' vector vocabulary seems to be insufficient to write description. Okay, back to Adrian.
All right, Chrisantina, you said
yeah?
to be having problems with geometry and plotting points to show vectors. All right, that's a good. All right, I don't have a problem with that point. Did you give an example?
Well, looking at the question.
I saw the question, but what you need to do when you're saying this, you have to refer back. For example, when the student did so and so, so you need to be. Are you clear with what I'm saying to you? We looked at the question first, but then you're drawing a conclusion that students seem to be having problems with geometry and putting points to show vectors. So you need to refer back to the question as to why you say this.
Okay. Okay. Well, based on the report, it was mentioned that students did not draw the vectors properly when they were asked to, they were given their position vectors and they were asked to represent it, and they didn't do that very well. They asked to draw BA and BC, and it wasn't done properly.
Okay.
Yes. Okay.
Okay, on to 2013.
Yeah.
Okay, so again, looking at this question, you will know that the requirements of the question, right? Students must be able to use vector geometry to determine the resultant vector. Also, they must be able to use vectors to solve geometrical problems, right? Now, once again, even though the percentage attempt for these questions in 2010, it was around about 28% that attempted these type, well, 21%. In the latter years, we have a percentage increase. However, the mean results on these questions, or the mean mark, they are still relatively poor. In this case, this question, 2013, was marked out of 6. So out of 6 marks, on average, students would have only scored 1.2 out of 6. So again, this is unsatisfactory. Now, based on the question and the diagram, the first thing you will realize is that students have poor observational skills in relation to the vector quantities, right? They fail to notice geometrical relationships between the different points on the diagram. So they were not able to tell whether the lines were parallel, if one was in relation to the other in terms of quantifying it, if one was 3 times the other, if one was half the other size, or even if they were equal. These are things that students fail to observe. So they had poor observational skills. Also, again, it's evident that they did not grasp prerequisite topics in order for solving these types of problems. And this is a common error right throughout from 2010 going on to 2013. Again, they are not able to link the different areas in the curriculum. You will notice that the question of algebra, representing these quantities using algebraic expression, that is a requirement once again, and students feel. So what they do, they actually think of the questions in isolation. They are not able to make a link, right? Especially with the geometrical topic. So they are not able to transfer their knowledge of algebra over into geometry. And so this is once again a major problem for students. And it's also evident, and this is a common error, recurrent error, that students do not master the topic area of vectors. So they cannot relate to the triangular law, for example, right, to solving vectors. Once again, they cannot relate to the vector quantities as coordinates so that they can actually trace the direction or the movement of a vector on a Cartesian plane. And so on, based on the attempt and the mean mark, we also have to consider the fact that this question, the vector questions, they appear at question 11 on the paper right throughout these years, and it's on section 2. So there's a thought that maybe the pressure of time in terms of efficiency, that may also affect students' thinking, but the outcome is that they are not able to manipulate different thinking or different avenues of arriving at a solution, and they are not able to link prerequisite knowledge into solving these questions. Here, you can move the slide now. Okay, for the kid, from 2010, 2011 as well, and 2012, the examination had been focused on trigonometry and geometry. Vector questions were not included, not in so much. So these are taken from section B, module 2 of the paper. However, on the 2013 exam, vector quantities were included, right? Now, for the 2013 exam, students were required to use geometry to determine the resultant of 2 or more vectors, right? And of course, this requirement is similar to that of the CSEC examination. Students were also required to use 3-dimensional vectors to solve problems in geometry, right? Now, surprisingly, the rating for this performance was satisfactory, right? So, in general, students pass the average mark for these questions, right? However, it is still evident that students had poor observational skills and failed to establish relationship with the vector quantities once again. For example, students were not able to identify equality among vectors, which was the case in this particular question, right? The students also failed once again to transfer knowledge from other areas or strands of mathematics to apply it sufficiently to vector quantities. And once again, they also lacked conceptual understanding in the topic area of vectors and could not sufficiently proceed to answer all the questions, especially those that required some bit of higher level thinking, right, as it relates to other topic areas. So those were the major concerns for the CAPE 2013 examinations? You have anything to add, Chris?
Nothing to add. Any questions? Any comments?
Any question?
Ms. McCarthy, I have a question. This is not particular to anybody's presentation, but I would like to know, from my own, I guess, ignorance, because I don't understand, why would the Caribbean have two different exams, like the CAPE and the CXC? And
there are different levels. The exams are done at different levels. So the CSEC is done in 6 months. The CAPE exams, so the CSEC exams,
yes.
That's done in at the end of grade 11, and the CAPE exams are done in grade 12 and 13. So the exams are at different levels. So, like for example, let's say you're in grade 2, you do an exam. When you get to grade 3, you do another exam. So for the
GCE, O level, and A level.
Yeah, it's like GCE, O level, and A level. It's the same thing.
Oh, okay, all right.
Yeah, so they're done at different levels.
CSEC is O level.
Are you clear, Arantos?
Yes, I'm clear now.
Alright, so the O levels that you do to matriculate the A levels, the CSEC is our O level and that CAPE there is our A level.
Okay.
Yeah.
All right.
That makes sense.
Yeah, that makes more sense to me now. All right, thank you.
Alright, are you clear now?
Yes, ma'am. Very good.
Alright, so we're going to take a break for half an hour and be back by 11:30. Then when we come back, Donald and Jomo and Kenzie will present. Please remember that you need to see all presentations because you need to do your reflection on the presentations. Remember you have work to do. Am I talking Spanish here now?
No.
Listening, miss, but I'm not understanding.
You don't understand? Oh my God.
Say again, miss. What were you saying?
Remember that you need to look at the different presentations. You need to see all the presentations so that you can write your reflection. Remember you need to write your reflection on the insights and stuff that's on your assignment schedule.
Is that all? Should that also be done as a group?
No, that's
Okay.
And when I get back now, Casey and Joe will present, then Donna will present, and then I need to go through the different things, go through the different presentation, and we give our opinions about what we think went good and what
Mr. McCarthy, can I read the line after you come back?
Oh, sorry, I didn't remember about you.
That's okay.
Yes.
I have a question too, because Rick said he sent you his portion. Did he send it to you or not?
I saw an email from Rick, but I haven't gotten the chance to really look at it properly yet.
Okay, I'll just work from my end. So do I? This one.
So you'll go after Donald?
Okay.
Okay. So is there anything I can help you with? You want to send that email to you, Crystal, from Rick?
That's okay. Yeah, I guess so. I don't know if he. I just want to know if he had his portion attached to. Did he include his portion into what I had sent you?
Okay. Well, it's your decision.
Well, you can send it to me. I just didn't know what he had sent you.
Jesus. Okay, I'll send it to you. You want me to wait for it? think I need some coffee. That's what I need.
That is a monastery at the elevation.
Crystal?
This is called the place today? Or this
Yes,
morning?
she came here this morning.
Great. Yes, we were supposed to meet, but afterwards I was late.
Yeah.
I told her I was going to do it.
Yeah. Let's go. Crystal?
Yeah.
I looked at what he sent me and there's no attachment. And this said an attachment.
Okay, that's fine. So
Okay, so
we're
remember.
Ms. McCarthy, in terms of if we're not using the proof, that means I get last point.
For what? Because Rick did not do his. I'm not understanding. Could you answer the question again?
I was asking the question, what does that mean if this is a group presentation? Do we get last mark because we're not doing it as a group?
But you said that he contributed, so you get that mark. If he's not doing well, then he's not doing well.
No, that's what I mean. No. I mean, not that part. I mean, we had to put together. He helped me with. I don't know. Anyway.
Good
I'll
morning.
work with it.
What's she saying?
She was there, she done something anyway. Basically, like, this time running and talking about, I just tell me that he helped you. Like, I'm not saying that, Orantis. No.
We already said that part about you.
Right, like he didn't have a presentation, then he
Mix it up, yeah.
And I'm like,
You already said that was good, that shrimp, shrimp fettuccine, and we got it from. Put in.
and let me see.
You spend up there, I go here and bring you, bring you the hand.
I have
That's
not
gotta be a good one for after, I'm sorry. There's just nothing.
I'm not gonna lie for it, I'm sorry.
And that app, you was the one who got the app, right, for the Matrix, right? Yeah. So what did he really, he didn't really do anything either. I'm gonna show you what he sent me. And that was this morning, I'm like, well, why you didn't send me that last night, when you was already finished? And he would have put that app on the inner, when you need to say, this is the app that I good to you. I said, wait, this is it. I didn't know what this is. We could be saying anything. That's why I can't put the two words together. Cause you know. But everybody's still pointing out, right? I was wondering why you were way behind.
Hey,
Horrendous. When I went downstairs, you were way behind.
I can't remember when I've done that.
Can't put on the bus. But then he was sick yesterday. Why not send that email last night? That would have solved the whole problem and you would have presented it. Right? But now y'all are still different doing, so what does that mean? I will remain.
I'm irritated. I just want.
Yeah, you really got rid of one last night because I knew he was coming back home. And he was not sick. He was not sick like that when he was on the phone. The first time. And for you to be a wallet again, don't get back to me.
It's full of it, because he don't come
You're gonna
by.
come sit in your mom's car and go down to her. And put your rubber on to me. The boy to say, this boy is going to be at the beginning. Adjusted it. That's the Russian.
I don't know if this is right.
You can copy and paste that into.
Oh, your computer's just a little bit slow.
So they here's person I do, that's what I was doing last night. I'm copying and pasting this thing. Then I'll change the font.
serious, girl. Good dresses. That's right. Sounds like what we had on Sunday.
She nasty ignorant and watching the did she get him?
No, of course not. Yeah, she likes us. I'm into some pieces. I don't know. I'm like frustrated because I feel like I can't really use this screen. Grab it. 1, 2, 3. 2, 4.
They took Keith's mom down.
Really?
Which is so weird. Because Keith's mama and daddy are sick. And his daddy's daddy's wife is sick.
What?
And none of them died. I mean,
But
that's
her
sick.
mama just like.
And her mama just died.
Yeah, that's it.
But you know what hers was from doing like friends, or her friends with woman, like how closest relative that she was really good. Her sister died like maybe a couple of years back. So she's been, no, my sister, but the end, she got close with her cousin. She was close with her cousin, she was 3 of them. And the cousin died a couple of years ago. So, Okay. You know, you have your good friend, somebody out there close to you, going.
Right, right.
$7:30.
Did you get to speak to Miss Owen?
Mm-hmm. Cause she informed that. And of course, this morning I was gonna do it.
We had to read it in because I know how he's gonna go. I bet you if she was to go on this readers,
She's up.
they wouldn't know what to do. Yeah,
She's up.
that's true. I don't understand why she wasn't expecting me.
She said it back straight when you said.
That's a language.
Mm-hmm. Pretty much what he said. He said it's finished here. Listen to this message. It's October 14th. Oh, no, you do it. And they keep saying it. Into their program.
It's not like a woman.
It's a long message. And they keep saying that. It's Christina, your cousin. It's Christina, your cousin. I don't know who that is.
Okay. And, we'll go on a break.
So yeah, I quickly asked her, she said, they don't know, they haven't got the autopsy report back yet, but, she said she was fine. She hadn't been eating for the last 2 days. So remember how I told his mom, Daddy was like that, where he was eating. And she said, on Saturday, she fed us some, she was drinking, so they didn't bother to take her to the hospital because she wasn't eating because it was hot. So because she was drinking, they didn't worry about taking her to the hospital. Plus, she didn't ask to go to the hospital. So then, Saturday, she said she had something to eat. She said she was up in the room, it was really hot, but her mom kept on saying, no, I don't want even to say this. She said, well, why don't you come downstairs? So she came downstairs and everything, got dressed and everything, got downstairs. And she was sitting downstairs, and she said, this was Saturday. She had a hot dog that day, or the day before, and she had asked for some food. She said she'd come downstairs on Saturday to get some food, but when she went to eat, she probably took a couple of bites, and then she says, I don't feel good. I feel bad. I feel bad. I feel bad. Why I feel like this? I feel like this. So she never asked for the hospital. She never asked for it. She never, asked to take the hospital. She just kept saying she feels bad. So they called the ambulance at that point. So then she said, I see double. So she said, so then she just kept saying she feels bad, she feels bad. She don't know why she feels like this, she feels bad. So then she said, Gina and Ian were up to the road at this point now, and she said she was the only one down there. And so she saw her going like into a slump. So she put her hands over her face and she said she wasn't blinking, right? She was just staring. And then she saw her teeth drop, and then her jaw drop, and then she said she just saw her take this like a last breath. And just as she was going to do that, the attendant came in. So he had to, resuscitate her or whatever. But they were not able to resuscitate her by the time they got to the hospital. So they took her to the hospital, like her brother's her and everybody's her. So they told her at the hospital that she had a coma. And they weren't able to resuscitate her. But she's, and now, in reflection, and I was saying the same thing to her, that, she never asked for the hospital. So she thought it was great to go because, her cousin, her sister died, she was born. And then the cousin just died a couple weeks ago. So it's been like, who've been talking, they talked every day, and it even got to the point where she said she told the daughter, if my mama calls you, she might call it again. Sorry, I haven't. Because she had a arm and times, right? So she said if she calls and, she might forget this was born.
Santiana? You're here. Okay. Adrian?
Yeah, here.
Okay, I'm seeing Bermuda, but I'm not seeing Crystal.
So my laptop guys are so Crystal is trying to update her information using the laptop that we have here on the site.
I didn't hear that.
Okay, so Crystal was trying to update her information on my laptop, but my laptop died, and I don't have the charger. So she's now updating the information on the laptop that we're using for
class.
the class.
All right, no problem.
So you won't see us, but we can hear you.
All right.
Yeah.
She said she can't see Crystal. She
Can't see Crystal. Yeah, she can see us.
So Crystal is still here, but she's sitting right at the front here. So, you know.
Alright, so we're all ready now? Alright, so Jomo and Kezia, they're going to do their presentation now. Can you hear? Can you hear them?
Yeah, we can hear you.
Alright, good. Can you see the PowerPoint on the board?
Yeah.
Yes.
Alright, good morning Jamaicans and good afternoon Bermudans and St. Lucians. I hope we are not sleeping or we don't feel sleepy. We will not be long or we had your coffee. We will not be long and we try to be as spicy and very vibey as possible. Alright, can everybody see what is on the screen right now?
Yes.
Yes.
Right. Now, what do you notice is happening here? You see a triangle on the mountain?
Some triangle.
Okay.
I see some triangles on the mountain.
That's the only thing you can see there?
I see a reflection in the...
See a reflection.
Oh, wonderful. So, we are going to be talking about transformation geometry, and specifically we're going to look at the errors that students make when manipulating questions that involve reflection, rotation, and translation.
Miss Santiana, are you following?
Yeah.
Okay, PowerPoint was sent to your email, just in case you want to follow on your computer. Alright, so yes. So Joe and I will be conducting the presentation.
Why is
There it's there. But you have to go pull up everything else, like you attach that to PowerPoint.
just the part?
Let's put the attach the thing to it.
That's no problem. Because I sent it wrong.
Alright,
Yes, it's again,
morning again, Jamaican, afternoon, Bermuda and St. Lucia. Alright, so I have the reports for different years. For May, June 2010, errors were described rotation. The students were not describing the rotations completely. And they were saying that they were not using, they were using informal language. Now,
what do you mean by informal language?
alright. When I look through the whole years, alright? And this is generally what I say. The CSEC report is saying students know when it's a rotation, like when it's a rotation, when it's a reflection, when it's a translation, students can tell. The problem that CSEC is having is that, for example, in May, June 2010, it was a rotation. But CSEC want them to stay is it's a rotation, 90-degree anti-clockwise, center of rotation about the origin. Students, they're saying that the students can say that it's a rotation. And then students were talking about leftward, westward motion. So that's what I mean by they're using informal language. And throughout all the years, that's what we're seeing. We keep on seeing that they're saying poorly done. We keep on saying poorly done. But when we're looking at it, it is not that the students don't know a rotation from a reflection. The students know when a rotation is there, they know when it's a reflection. But it's just the language that they are using. But in 2011, it was a reflection. They are saying the students knew it was a reflection. They're just not stating the mirror line. Mirror line being x equal 2 is a mirror line. But they're saying students will know it's a reflection. Reason we did January 2011 because we didn't say any rotation reflection in May 2011. In 2012, again, the same problem again. A reflection question, they're saying students know it's a reflection. They're just not stating a mirror line. 2012, again, well, this year actually was funny. They actually said that students were unable to distinguish between anti-clockwise and clockwise rotation. It's still come out the language. 2013, unable to state the mirror line, could not describe the cutout. I think 2013 was a combination. It was a rotation, yeah, a reflection and a rotation. Yeah. That was the error here. Alright, so we're going to the suggested causes of errors found in transformation.
Alright. So I want to know what would cause this error to be occurring almost every year when a rotation question is given. Now, we suggested that the language used by the teacher when teaching, teachers don't use the word anti-clockwise or clockwise when they're teaching. So they would say, see students, the triangle went 2 spaces to the left, or it moved 2 spaces down, or it did not move, etc. Or it just slide, or it just, so they did not use the appropriate language for students actually hear and be comfortable with. Also, the correct mathematics jargons are not emphasized. An example. Oh, you give one example.
Right? And thirdly, students are not encouraged to use the mathematical language. So for example, if the teacher has an image and an object on the board, and they would say, so students, explain what's happening, what's the difference between how did the image move, the object
transformed and reached at this particular spot. Students would probably say, miss it, move one space down, or etc. And the teachers don't grasp the, talk about the problem right there. They just say, oh yes, thank you very much, and they move on. But students are not encouraged to use these words. As you know, clockwise, right, we don't reach the clockwise. Students need to be encouraged to use it, because some of these math languages are not used in our daily life, right? So when they come to the math class, that's the time they should be. You should emphasize that they use the math language. All right. And the other error was students were not describing a transformation completely. Notice the word completely. Whenever CXC gives a question like a question involving transformation, they would boldly write the word, describe this transformation completely. Sometimes they boldly write the word completely, they underline it, etc. But students, they do it, they partially describe it, but not completely. And we say that teachers fail to emphasize the main features needed for describing a transformation. And emphasis is placed on the different types of transformation rather than the full description of each type. And I myself, I am also guilty of that, because I can recall going to the classroom, I would say, so students, anybody can remind me of the 4 types of transformation, everybody can tell me. But I hardly go in there and go in for the specifics, for details, for the different features. Asking them to describe, tell me how exactly a reflection in the y-axis looks. What are the main features? When describing a reflection, what are the 3 or the 2 things you need to put in to get your full marks, etc. So teachers do not fully explain or emphasize the main features that these transformations should have. Because as you know, you cannot just reflect something like that. Something has to happen. There must be a specific feature that this image should have, opposed to a rotation, etc. So that's one of the reasons that we came up with for students not describing the transformation.
The next one was, I think it was 2012 it was, it said about clockwise and anti-clockwise, and we're saying that students were not exposed to the real life situation that involved the words clockwise and anti-clockwise. And an example of that was showing was this. A teacher might stand up on the board and say to the students, this is clockwise, pointing towards them. What if?
That's a very good point, Jomo. Very, very good point.
If I'm pointing right here, I would say, students, this is clockwise. But in the student's mind, it looks anti-clockwise. So what we're saying is that instead of teaching them, standing up on the board, set out a clock on them. Get a clock.
Give them the clock.
Yeah, or put the clock and say, look, this is clockwise. Make they see that, okay, clockwise at this rotation. But if you just stand up on the board, if you don't look at it from their perspective, what they are seeing, they will think that, okay, when you're pointing this way, they are seeing clockwise being in this direction, and so they are now then writing down clockwise, mixing up the clockwise and anti-clockwise. And that was teachers when physical demonstrate. Oh, okay, yeah, let's see everything again. Teachers when physical demonstrating direction, standing opposite direction to the students. And in the last 2013, the error that was said is taught again. Why is that? We feel that transformation are taught in isolation. Because when it was in a combination, they show that for this particular year, students struggled when there was a combination. But for all the different years, it was like a reflection, students would see a reflection. It was a rotation, students would see a rotation. So they showed that the students knew when a reflection and a rotation. But the combination, that year, they actually said it wasn't a case of students not using the correct jargon, they just had a problem overall topic. So I feel that transformation and chart in isolation, students are not exposed to transformation and involved more than one time, meaning they show a student a reflection, also give him a rotation with as well. And don't just teach him it as rotation alone, reflection alone. That's it.
Yeah. Any questions? Is there any question, anybody? Oh, by the way, transformation is not.
Yeah,
okay.
At the Cape level, if you look at the transformation for like before, well, take it out of the syllabus of 2012, and if you look at transformation before, we talk about stretch, like they have sine x amount to sketchograph of sine x is a vertical, it wasn't really good with reflection or rotation.
Okay, right. So there was no.
Oh, we did talk about the translation. They did the point I think I did mention. Let's make a point. I remember, let's go back to the first stage. The error with translation, they actually stated that the students could use a translation, but they, where was it?
Wasn't there because it was really
important. Remember it from point. The error was that it was a translation question. They actually stated that the question asked for the coordinates under the translation. Students had the correct answer, but they weren't writing the coordinate form.
So that wouldn't be a transformation error.
But that's still an error.
It's an error, I guess, a coordinate.
It's still an error because it's still an error now because these are common errors that students will make. Yeah. But it's not a translation error, but it's a prerequisite error. Just like when
I think that's one of our
Adrian, he was saying that because they don't understand. So we have to, like, even though it's like a translation error per se, we have to understand why the student made the error and why it's important for the prerequisites to be in place.
Yeah, I think the vector form, so because I'm at the vector form, then just leave it in vector form. The error was that they should write it as a coordinates, because that was what the question asked. But I guess it didn't really be, because they did the translation properly. So I guess it was their card. Yeah. But it's just true that was part of it. But let's remember it.
Alright, any questions for Joe and Kezia?
No.
Alright. So I'm gonna ask what you think of the presentations when we're done, you know, so make sure you're paying attention. Good job there. Donald?
Yes, miss. I'm right here.
So you need your thing to be sent?
Oh, yes, miss. I sent it to you.
Alright, let me go on. Did you send it to everybody else?
No, miss.
No, you sent it.
I'll send it.
No
worries.
No. I remember
yeah, but then change something on it.
Oh, because I'm not sure what I'm going to say. Error mismanagement.
Donald?
Yeah.
Donald?
Yeah.
Can you give me a minute before you begin?
Okay, I will.
Alright, soon we'll be back.
Okay.
I think there's already no one. You can send one already.
It's there. Errors, misconception, and circle.
Yes. I think you can send me some changes.
It's there. You send the first set of steps. It's in the first email that she sent, talking about PowerPoint. Donald Dewey? Dewey? Dewey?
Okay, I'm back. Thanks.
Yeah, but you need it faster to become a
Just one class.
This one?
Yeah, 2026.
But I'm not sick, I can't see it.
Oh no, you don't have to see it.
Sure?
Yes.
The only thing you need is PowerPoint.
Oh no, you just close the last one. You did it last year.
Okay.
But you didn't see it, you didn't want to see it.
Alright, so this one you want?
This was. What is this?
Alright, everyone, you should be able to retrieve that PowerPoint right now. It's a new one that was sent for Donna. Bermuda,
Yes, ma'am.
have you received this PowerPoint?
Not yet. I haven't received it yet. Received it, Rosemary?
Adrian, what about you?
Yeah, I can see it.
Have you received it? I sent it via email.
Okay.
Santiana?
Not yet.
Alright, let's give them a few minutes so that they can. Oh, please. I think that's actually the most easygoing lecture ever. Why should I do that? I understand.
You see me can go, it's not hard. And then anything you feel like you want, but no say, I present it here. Just the nervous,
Second one, THO.
Alright, have you received it yet?
That's a button?
No, not yet. We usually receive it sort of late. So.
Let's see, let me go and check. Pick us up. I just want to be sure that that's sent. It was sent.
I think that's something else, yeah. Second? 3 minutes ago. I don't think.
Oh, Joe.
Man, that's Joe, man. I don't stay.
No, hello.
What I mean, me read. You're supposed to do
Get everybody to
Kids, I'm like, Joe, man.
Alright, are we receiving now?
Yeah.
I come in the rest of us now. Please lay down here. Keep me nervous. Oh no, I don't put him under pressure.
And I just hear a grade up. See a cigarette.
Do not do
Right.
I was going to use her on that she sent everything.
Yes.
like all of us get those faces to each other.
Yeah, you cut off the piece over there, so, but yeah, I've seen everything. Thanks.
This one is not there.
This one is not there. And Adrian is there, Cassandra is there. Alright, good afternoon everybody.
Yeah, good afternoon.
Alright. Presentation this evening is on errors and misconceptions on circuit theorem. Actually, it should have been myself and Stacy presenting this afternoon, but she's not here, sadly, so I'll be the only one who will be presenting for this group.
Should we deduce that you're the only one who does the work?
Oh no, I will be the only one presenting today. Only one presenting, but of course she did contribute, guys, don't worry. No, well, she shouldn't worry. Alright, next slide, please. Alright, so basically, it's a well-known fact that for CXC mathematics, the failure rate is particularly high. And one of the reasons is because of the misconceptions on the students' part or the inadequacy of the teachers in adequately preparing the students for this exam. And what we want to do is look at these misconception or inadequacy by analyzing all the CXC reports from 2010 through to 2013. But we're doing this using circuit theorem, under the topic circuit theorem. That's our topic that we're looking at today. Alright, so when we look at the option circle theorem, what we would immediately recognize is that in some cases, almost half of the students chose the option with circle theorem, which somewhat implies that students had a general idea, they had a certain level of confidence in doing this option. But that is the problem with this option. They only had an idea of what to do. They really weren't sure of what they were doing. Next slide. If we look at the CXC report from 2010 through to 2013, we would recognize that there is one sad recurring theme. And that is that even though the students were able to state the size of the angle, they were not able to give reasons as to why the angles were, they were not able to give reasons as to why the angles were what they stated that they are. Everybody following me?
Yes.
Am I clear?
Yes, clear.
Yeah. Okay, first one, Shanna, you follow it? Chrissy?
Miss Aitana?
Oh, I'm saying I wonder if it means yes, I'm following you.
Okay, good, very good. Alright, and what we would recognize also is that throughout the following years, you would recognize that also the students did not recognize the instances to use the theorems under circle theorem. Also, they made some incorrect assumptions. Next slide. Alright, so we're on this slide now, and we're looking at the first misconception here, or the first error, or the first thing that they did that was not up to par with CXC standards. And that is, even though they were able to state the size of the angles, they could not give reasons as to why. Now, this was one of the questions that they had commented on. Now, you can see this figure. Now, one of the angles that they were asked about, sorry, I don't know why this O is here. This O should have been here, and the Y should have been between the T and the V where this intersects. And one of the questions were to state the angle X, Y, Z. Everybody following?
Yeah.
Yeah.
Good. Yeah. So they were supposed to state angle X, Y, Z. Now, most of the persons were able to say angle X, Y, Z is actually 116, but they weren't able to state why angle X, Y, Z was actually 116. And we're just going to move on to the next error. So yes, here is what I just commented on. The students, this is actually taken straight from the CXC report, where it says candidates generally knew that the measure of the angle was 116 degrees, but incorrectly stated the reasons for this. All right, the next example is where incorrect assumptions were made. Oh, you can bring up the 2010 CXC paper. It's supposed to be on it.
It's down at the bottom. It should be escape, and it's down. If you look down by the task bar, that's the task bar. Oh, that's it.
Alright, so everybody's seeing this picture that I have up here with the question of circle theorem, the circle theorem question?
Yeah.
Okay, very good. Bermuda, you've seen it, right?
Yeah.
Very good. Alright. Now, one of the assumptions that they had made with this circle was that triangle TPR or PRT was actually an isosceles triangle. If you guys look at it, do you see an isosceles triangle?
Yes, the one right here.
I mean, this one right here. Does it look like an isosceles triangle?
Yes.
No. Alright, so let's take a show of hands. Who says it's isosceles?
Really?
So we have one believer. Any more believers? No. Unfortunately, no. Guess what, guys? We are wrong. What? We believers are wrong. This is actually not an isosceles triangle. And these are some of the common misconceptions, common misassumptions that were made in trying to calculate the size of angles and the length of lines.
To clarify for Rosina why that is not an isosceles, what would have made it an isosceles triangle?
Alright, for this to be an isosceles triangle, it has to have two equal sides and two equal angles. The only way that would be able to happen was if this was actually a 90-degree angle.
That's correct.
But it is not.
The line comes to see that way. My point is that, what is that point on the line? No, that's not my point. My point is right here. That makes it an
and it's not like they pass through the radio, say what I said.
Yeah, you can pass
Okay.
You don't have to tell anything. Unless you see it.
I'm looking at this one like this way, like this. That's the eyesight solution.
Okay.
See?
Alright. John was also adding that.
Well, what I'm saying is that the question stated that PT and PR were equal. It would say it was an isocycle. The question stated that TRP and the RTP were equal, and it would say it was. The question doesn't state it, you can assume it. However, if PT was, if P was like, if it was O then, replace P for the radius as a radius and the total pass. You wouldn't have
to any point in the circumference.
Same size.
Yeah. Unless you say that they can assume.
Yeah. Very good point. Did you hear that point, everyone? Rosina, did you hear that point? Unless it is stated, unless the dimensions are stated, you can't assume that the distances are the same. So if it's not coming from, yeah, let's just leave it at that.
Alright. Another thing that students incorrectly stated. Alright, we can just get to the 2010. We're just
go back to that?
Yeah. So very quickly, another misassumption that the students had made was that TR was a diameter. Everybody seen TR?
Yeah.
Yeah. So that was another misconception or misassumption that the students had made, that TR was a diameter, which clearly it is not. Alright guys? Alright. Let us look at the third error. Or a misconception.
Which angle?
What caused those errors? You tell us before you move on.
Oh yes, miss, we're going to
go
back to this. From correct side. Alright, and so here the last one that they had stated was that throughout the years, the students did not recognize the instances in which to use the theorems, of course, under circle theorems. So it was saying that most of them were unable to interpret and apply the alternate segment theorem, and some of them were unable. And alright, take for example, there is the theorem that says the angle at the center is twice that at the circumference, which means if you want to find if the angle at the circumference is subtended by the same chord that subtends the angle at the center, then the angle at the circumference, you have to multiply that angle by 2 and you would get the angle at the center. But what some students did was multiply the angle at the center by 2 to get the angle at the circumference, which was incorrect. Everybody followed?
Yeah, I understand.
Yeah. Alright, cool. Now, having looked at these errors now, next slide. Oh, by the way, guys, is there anything that you want to add in terms of misconceptions and teaching errors from your own experiences of teaching circle theorem that I probably have missed? No? Okay, guys.
Yeah, one thing.
Yes, Adrian.
Yeah, circle theorem, what you realize is that students need to do some reading to actually remember the theories. And when it comes to math, well, my students, they don't like to read any at all.
Math students in general don't like reading.
Math students in general don't like reading.
Especially math, you guys were math specialists.
Alright guys.
So I have something to add. Before you move on. Look here, I think that when we're teaching circle theorem, the idea of, because circle theorem has a lot to do with angles. Alright, fine. me to go there. I guess he has that plan. Oh.
Alright, so what we want to do now is try to figure out why it is that the students keep making these mistakes on the paper. What we want to do now is find out why it is that the students, even though they're able to, in some instances, state the actual size of the angle, why is it that they're not able to give reasons as to why the angle is what it is? Why is it that they don't use the theorems properly, and why is it that they make these wrong assumptions? Anybody?
Well,
you want to know why
Crescentiana is answering it.
Crescentiana?
I was just saying the length of time at which they're exposed to the theorems. It's
very good.
Sometimes they're exposed to it very close to exams, and it's a lot. And also the manner in which they're exposed. If we just give them the theorem, then obviously, like Adrian said, they're not going to read up on it. You have to. It's something that they have to practice.
Very good. Alright,
what I don't know is that if you don't if you don't mark for a reason, like for example, like in my when a student give me the angle, give me the mark, I always ask to give 1 mark for the reason. So if you have a 2 mark, 1 mark for the correct, 1 mark for a reason, you have some. And my mark it, my mark give out 1 out of 2. And when you come to me and say why,
never give any reasons.
After state the reason, and then I say reason is important. I say yes, because in the exam, they have students who just think that just giving the correct answer is sufficient.
So you have to culture them.
Yeah, you have to make them know that reason. When you go to tell them why they give the wrong reason, but I know say you have students who know the correct answer, but don't write on the reason simply because of just thinking that the correct answer is a full one.
Alright, so my addition to this though is that one of the reasons, for me, one of the main reasons, or should I say for myself and Stacy, one of the main reasons why the students make these sort of mistakes is because they don't recognize most of the times that, for one, the diagram is not drawn to scale. A lot of times the students look at the paper and in their head they're saying, well, this thing is drawn to scale. They're probably thinking this is an equilateral triangle when it isn't an equilateral triangle. They're probably thinking it's an isosceles triangle when it isn't an isosceles triangle. They're probably thinking we could apply Pythagoras theorem here when actually they can't apply Pythagoras theorem. It's not right angle. So because the students repeat?
Sorry. I was just saying also they don't know how to estimate, because if they give you an angle and they said that it's 64 and the other one looks bigger, then obviously it has to be a greater value, but they don't try to reason. They just drop an answer of it.
Very good.
Very good point.
Very good. So exactly. The student, oh sorry, Kiza, I'm so sorry.
As it relates to the diagrams again, I don't know if you realize it, but 1 year, CXC, it was supposed to be a cyclic quadrilateral because because I realized, because you could not answer that question without it being cyclic. But CXC, I don't know if it was ink or something that year, but one of the corners of the quadrilateral wasn't touching it. And to me, that posed a problem to students, because teachers tell them it has to touch the circumference. And so sometimes the diagrams really can throw off students. So it's not just that, okay, it is not drawn to scale, but they give them a very bad just poor.
Alright, everybody heard that point that Kiza just raised?
Yeah.
Can you repeat it a bit, Donald?
Repeat. Okay, alright. What you were saying was that sometimes it's not only that the students take the diagram as being drawn to scale, but at times the diagram isn't constructed properly for the students to use the circle theorems, because she was given an instance where a piece of the quadrilateral was actually outside of the circle and not touching the inside of the circle. Now, we know, or as students, in their minds, it should be touching the inside of the circle. So probably there will be some amount of confusion, and the students will not necessarily do the question properly, even though they were trained to do the question properly. That's the point she raised. Alright.
Good point.
Alright. So, of course, if you want at this point, you can make some little notes so that when you go back into the classroom, you know how the students think and try to correct these little problems. Alright, guys? Does anyone else, have anything else to add? Alright, next slide, Joe. Alright, so what causes the students to have these misconceptions? One of the first things is that students, as Krishantiana so correctly said before, they're not really given enough time to explore the whole concept of the theorems. A lot of times the teachers come in, they said that this is the theorem we're looking at today. They put some problems on the board, expect the students to do it, and then they move on. The students don't really grasp what's happening. To be honest, at times the concept is so abstract that they're able to what you would say, match.
It's not abstract enough.
It's not, but to them it would, because they don't have. Yeah, you just throw something on the board, and after you throw it on the board, you give them some questions without them even understanding the basics of what's going on.
You should measure, you should give them these angles, coming from angles. So there's general ideas that that are evident in working general angle question. They're still going to be needed to apply to several theorems. So you have to start an angle concept, like developing the whole idea of angles. Yes. So exactly, the whole idea coming from the whole ideas of angles. So even when you draw some things, you need to start having them using their protractor. This is important. Measuring them and drawing their own conclusion.
Sometimes, it's a whole, because, for example, you have some schools, you see, if you have a string group, they'll say, alright, since you have that strong group there, go into the whole idea. But if you have a weak group, them say, no, nobody.
And the weaker ones will appreciate it more.
But they might tell you, nobody do that with them, not follow. And them just tell you, just give them the theorem.
No, the weaker ones probably get it more.
And them actually tell you, when you have the strong group, yeah man, the strong group can go in and that figure out how the theorem actually comes out. Like, they even go into the actually prove, and then sit down and prove it, algebra, and draw and prove it as well.
You need to prove it, but there's something that can be measured. You need some systematic ones, very well drawn scale ones that can be measured, and they draw their conclusions from those. But you see happening, that's important. So even when you start from alternate angles, when you have alternate angles on the board, it should be, if you're saying that alternate angles are equal, then they should be using their protractors to measure and show that they are equal and draw the conclusion. Yeah.
So, Miss McCarthy, everybody heard what Miss McCarthy had just said? Please say yes. Alright, that's why that looks like a no.
No, I understand what she said.
Okay, good. Because she just discussed the second point that I had here. Students, they don't really physically explore the theorems. They're not measuring and understanding or seeing the correlation between what the theorem is saying and what is actually happening on the paper. So, because they're not really doing this, then, they're not really understanding what's going on, they're not really appreciating what's going on. And in the long run, as Christian just said, because the topic is taught so close to exam, they will necessarily do poor on this topic. Also, Mr. also brought up the point that certain prerequisites that we should have, such as the angles, measuring of angles, identifying of angles, they're not really understood before. So a lot of times what we could do as teachers is do some sort of introductory into circle theorem. Instead of rushing into circle theorem, we could do some sort of remedial course, or probably not take 1 day or 2 days just to go over these simple concepts or these concepts.
Revisit the prerequisites.
Okay, we need to revisit these prerequisites such that the students will, because to be honest, circle theorem is not really a topic that you do by itself. It's really a composition of things. And if you can't do smaller things, you'll never be able to do circle theorem. And that's just the fact of the matters. So this is actually correct. If you don't revisit these basic ideas, these basic concepts, then it don't make any sense to move on to circle theorem. So these are just some of the causes that I have outlined. Next slide. Oh, guys, is there any more causes that you know you would want to add? No? Yes? Maybe?
You're getting us to do the work.
It's a constructivism.
Why?
This is a constructivist lecture. Active. When we are as teachers construct our learning, we'll do better. They just tell us we won't do it.
Rosina?
Yes.
Any more errors that you'd like to add?
I'm just listening and taking notes.
Very good. Very good. Alright, so here are just some brief recommendations that I am making, that myself and Stacey are making, as to how we can probably try and solve these errors. Of course, they were discussed before, so we don't have to spend any lengthy time to go through them. The first one is that the students need to spend more time exploring the concept of the theorems physically. Miss elaborated on that, I elaborated on that, so we can move on. Right, guys? Very good.
Yeah.
Now, also, the students need to ensure, the teachers need to ensure that the same is done for the prerequisites, so that the students have the foundation to do the topic well. Of course, we just discussed that, like high fives. High five. Yeah, we just discussed that. So, of course, we also have to look. High five, Resina. High five. Very good. Alright, so what we have to do next, we definitely, because a lot of times we don't explain to the students that look, the diagram is not drawn to scale. Follow the instruction, read the instruction. To be honest, what I recognize with my students while teaching, they don't read the instructions. They look at the problem and they start solving it. As a matter of fact, I am very guilty of that. A lot of times I look and I start doing the problem, work out the problem, done in my class. Sorry, I'm finished in class, and the student said, "But sir, I know that the question asked." I'm say, "Read it." And I take the book and read it, and I say, "Oh my." So a lot of times, even us as a teacher don't necessarily read the question. We need to get the students to understand they need to read the question. The diagrams are never drawn to scale, and we need to get them to understand that. And lastly, we need to get the students not just to answer the question, but answer the questions giving reasoning. So once the answer, and Joma had made mention to that before, that once the student answers a circle theorem question, or probably any other question in math, we need to get them into the habit, let them develop the habit of giving a reason for each answer that they give. And each of these reasons must be coming from the concepts or the theorems. Alright, guys? And this habit is not something that they'll develop in 1 week or 2 weeks. It will take time. So of course, everything right here is kind of wrapped up in one. Okay, guys, yes, it's wrapped up in one. Good. So, what was the next slide? Okay, guys. If you have any comments, feel free to add in terms of recommendation. Are there any more recommendation? Feel free to add, guys. I think this guy's unzipping his mouth. Don't think he's zipping his mouth. It looks like he's zipping up, but he's not zipping up. He's unleashing, guys. Let it rip. I'm joking. He's actually zipping his mouth up. Yes, Adrian.
Yeah, Donald. Sometimes when the question asks the students to give reason for the answers, they have this tendency to keep writing equal at every line. For example, if they are finding an answer and they say, and you have to explain the answer, and they say CAB equals 60 degrees, then they are gonna subtract 60 from 180 now. To get the answer, they will write CAB equals 60 equal 180 minus 60 equal. So they keep writing that.
Yeah, and that would fall under prerequisite errors. As a matter of fact,
not necessarily. Let me deal with that one. That one is very important.
Alright, Mrs. is going to deal with that one.
No, Adrian, this is very important. When you have a math sentence, a complete sentence, you cannot have a complete sentence with two equal signs. So these are the prerequisites that students need to get. So whenever that sentence, you're working down the paper instead of across. Unless if you're working across, you need to be putting semicolons or something instead of colons so that this sentence here is complete. This math sentence is complete. So that is important. And I mean, I've seen that error even at the college level, students work like that. So that's a very big one.
Also, for that topic.
Who was saying something?
Yeah, well, I was saying for that topic, you have a lot of vocabulary that students need to be familiar with. Words like subtend, and the different types of angles. They need to be familiar with it.
That's true.
That's very good.
Very good. So even when we think that even though they've done the circle before, you got the parts of the circle, the sector, the arcs, the radius, the diameter, they still need to go back. There needs to be, for me, I'll put this vocab on the board for them to get the meaning of the different things. That's important.
Miss McCarthy.
Yes, Aranta?
I'll play devil's advocate, just for a quick second.
Really?
Yeah. I've kind of listened to everybody's. We have heard everybody's presentation, and I agree with a lot of things that everybody has said. But can we look at it from a student standpoint, as to say, in a testing situation? Now, I know not every student is going to have this, but very small percentages of them will have test anxiety issues. So could we say that some of the reasons why they are not doing so well on these exams is generally because they have test anxiety issues. They just don't test well. Now, I don't know how one solve that, but is that a possibility also?
That's a good possibility, but that is psychological. And we know that if we're very nervous, we don't perform at our optimal. Are you agree with that? If we're very nervous, because nervousness is good to a level, but if we're very nervous and anxious, then we don't perform as well as we could. So we're going to make what we call random and careless errors. Agree with me? So that's a possibility, but that's not something for me. I'm not a psychologist. You need psychological, that's psychological. You need to start retraining how you think of tests or think of exams. So, yes, students do not perform at their best because of test anxiety, or what we also have what is distinctive to math, what is called math anxiety. So the general thing that I don't do well in doing tests, but I just don't do well in doing math tests, specifically math tests. So I might not get anxious when I'm doing a language test or a social studies test or whatever, but I do get anxious when I'm doing a math test. So we have that also. We have test anxiety and we also have math anxiety. We have, I'm doing math and anything related to math. Math in class, math test, that is math anxiety.
Well, maybe it can be seen, because to me, I look at math as more than just a plain subject. To me, it's more like a science, because there's a lot that you have to do. You have to actually do it. It's something that you have to be practicing. The same way bio has labs, to me, there are things that the students need to do in math. Now, because of that, when you have subjects such as biochem and physics, these subjects have an SBA component which will assist the students in showing their capability in doing the stuff. So maybe math needs an SBA component as well.
Well, we've been saying that for a very long time, Crescentiana, but so far nothing has been done. So I feel you. I get what you're saying.
All right. So the final activity for the presentation, is everyone seeing what I have here on the board?
Yeah.
Yes. Okay, good.
Yeah.
Can anyone spot the error in
9-3?
in what I'm working out?
9-3.
Zoom. You have to zoom.
And also this is a product.
All right. You see it clearly now, Adrian?
Well, not entirely, but I can see to some extent.
I said I do it all the time.
Alright, so we have 49 is equal to 100 plus 64 subtracting 160 cos theta, right? And then, of course, in the next line, the correctly work, 49 is equal to 164 subtracting 160 cos theta. And then all of a sudden, we magically have 4 cos theta. Can anybody tell me how we get this 4 cos theta?
Let's subtract, sir. No.
Yeah.
If anyone is able to tell me how you get this 4 cos theta, it means we need to talk because you work magic. And I've always wanted to learn how to work magic. Now, this is one of the common errors that students make every single year while trying to work circle theorem questions.
It's not unique to circle theorem. It's
Exactly.
just non-right.
Common in trigonometry.
Exactly.
Yes, non-right angle. What is it? Non-right, work with non-right angle triangles.
Non-right angle, triangle.
How they do that?
This is one of the things that shows us that we need to give the students the proper foundation before entering into circle theorem so that they can easily gain 15 marks out of 15 marks for this question. Because in truth and in fact, the students are very confident with this question. They know what to do, they have an idea what to do, but because of the lack of practice and the lack of the teaching, they're not able to do these questions properly. Because if you look at the statistics, what you would recognize is that the mean for circle theorem questions is above average than the mean for all other questions on the paper. So thank you very much.
What does the math statement suggest?
Thank you very much for listening. I hope, I don't know, I shed some light on something in circle theorem today. Thank you guys, have a wonderful evening.
Alright, so
Okay.
before Rosina come with, she needs to come with her errors, cause for the errors, I can get that in her presentation, so she needs to do that. When we look at a statement like this, you need to ask students to interpret the question. What is it saying to you? What is it saying to you? This is a product now. They're multiplied, so students don't see this as a multiplication right here.
Multiplication.
They don't see that, and I was starting to think about order of operation. What should you do first? So because I don't understand the statement, the math statement, you need to ask them, what do you understand from this math statement here?
But is that same problem comes like I example like this, like 2 minus 5x.
Miss, you know something really funny, Miss, is if you should write an equation like that, but you don't have numbers using 3 digits, say for example, if you had 10 minus 5x, instead of cos, if you had x and so on, and smaller numbers, then they wouldn't make that mistake.
Alright, because they will see the product, they will see that this 5 here is the coefficient, or this negative here is the coefficient of the unknown.
No, but this, alright, that would go back to Adrian. This is what you're saying, and that goes back to a point that Miss has made before when she was saying that we need to stop teaching in isolation. Because when we're teaching stuff like this, we have the students identify that it's a product. But when we go over into trigonometry, we don't show them that the same concept that was applied in algebra is actually the same concept being applied here, because it is algebra nonetheless. We're just using algebra in trigonometry to help solve trigonometric questions.
Very good.
Okay, I think what, so for example, if I'm asking my students to solve simple equation, instead of using 5x, I could probably use other symbols are that could even use.
Something, yes.
Okay.
Because that would be the call is to shine off whatever is there. There's another point I wanted to make. I can't remember.
That's when you got it with that one.
I mean,
Alright, so Crystal, are you ready? Coming back to you now?
Yeah. Alright. Did you get my email I sent to you?
I'll check it right now.
I already sent it to everyone.
So all you need to give me now are the reason possible thinking that students will normally that will cause this to the errors.
Yes.
I just want to be sure you
Thank you.
because I want and so I'll treat the same. So.
Do I need to send this to everyone again, Crystal? No?
Yes, I did.
It was sent, okay.
Yes, miss.
That's the last one. Let's talk. Let's talk, Carla.
Alright, Crystal, you have 5 minutes.
Okay, no problem. So if you want to go to the first slide where we have the frequency table.
So that's what the possible errors are.
Which slide do you want?
The possible errors.
Possible errors?
The first, I can't, could you zoom out because I can't see.
Zoom the camera out.
Oh.
Sorry.
Little more, little more.
Oh, perfect. Thank you.
Yeah, right there's fine.
Okay, if you want to go to the next slide real quickly, so we could do the first. Yes. Go. Stop. Go to the slide. Thank you. Right there. That's
right there. Stop.
Perfect. Okay. So what I was saying that for the, although most students, they said a significant amount of students actually get this question correct, I would think that it would, because not all the students got correct, I think part of their problem might be is because they don't know how to add what it means to be, the meaning of cumulatively adding up values. So sometimes they may not see, and I've actually, no, you gotta go back. I'm sorry, you're going too far. The very beginning. Keep on going. One more. Oh. I can't see now, I see Adrian. Hi, Adrian.
Bar chart. Bar chart is further on.
Keep on going. All the way to the very first. Yes, right here. Yes. Yes. So they don't understand the concept of how to cumulatively add the numbers. So what I've done is I see how they don't know that 2 plus 11 and the value, whereas actually the cumulative frequency has to be added to the new frequency to continue, is the continuation. So that becomes an error. And if they don't get the table right, then that also can flow into the error in terms of how they plot the graph. So that's one error that I feel they can get a frequency table. If you want to go to the next slide, sorry. There we go. 1, 2, 3. Keep on going. Stop. Yeah, thank you. Oh, sorry. Okay. This error, I felt like they couldn't really, sometimes people don't know how to actually plot a graph, meaning how to plot the intervals on the graph. They have the numbers correct, but then when it comes to actually putting those numbers onto the graph, they don't necessarily get. So I'm just trying to read it. Sorry, hold on one quick second. Yeah, water, right, like this music. Okay. It's not, I'm sorry, I can't find my sheet. Why did I? Okay. I'm sorry, hold on one quick second.
That's okay.
Let me read. Okay. I'm sorry. I'm trying to read from the beginning because I can't see it. It was saying that first of all, in order to construct the curve, it always has to begin. The first interval should start at the 0 point, and then when you go to the next one, the plotting of every interval should be cut. Should be done cumulatively. Sorry, I don't know which one. Yeah, I can't really. No, I can see it. Hold on a second. I'm sorry, I can't really see the board and I can't see what you like to see. So I'm trying to pull up my PowerPoint slide. Sorry, you guys.
That's good. Because it's
Okay.
Say what slide it is.
Okay, I'm sorry. Wait a minute, make sure. On the ninth, you have it on the 9th slide, right? So basically, they don't understand what the first coordinate should be. So looking at this chart here, the first coordinate should be 10 to 0 because you always start with the y value of 0. So then going on to the next one, the second should be 25 because you take from the last of the interval to plot your point for the next interval. So your third would then be 30 to the 12th, or 30 to the 12th coordinate point. So that's a common error. If they don't know how to look at this graph or the table and find out how to get the coordinates to plot the Ogis curves, then they won't be able to do it correctly. Gemma, if you want to go to slide. And also another thing is they don't realize that they have to connect the points in a straight line in order to formalize the curve correctly.
The next one
The next one on slide 12, which I talk about, is the possible areas with not understanding the relationship between the vertical axis and the horizontal axis.
Yeah,
because the cumulative, you got it?
Yeah.
Slide 12. Cumulative frequency is dependent on the horizontal, whatever the horizontal axis might be. Let's do an example. Like I used, weight is dependent on how much one eats, or money is dependent on how much you can spend or save. So because those variables are reliant on them, they have to be plotted on the vertical axis versus the horizontal axis. So students may get confused and don't realize that cumulative frequency is actually it dependent on the frequency, so therefore it has to be plotted on the vertical axis. So if they may get it mixed up and put it on the horizontal, they're not going to be able to correctly plot the curve. Then the next one that we look at on slide 15, Jomo, is knowing how to convert how to calculate the median. PowerPoint, I'm sorry, slide number 15.
Yeah.
That's 15.
Okay.
Oh.
Hello? Abby,
Crystal? I don't know what's happening. Crystal?
I think your connection dropped.
Yeah, I'm here. I see. I guess I'll call us back shortly. No. When they go to them, they need to come back. Not right now. You don't want to know what you do, how you did that? Of course. I'm going to call you because you're going to get it here. Some of the costs is. Are you serious? Sit down. Joe, you were serious?
hello?
Alright, you're back.
I'm sorry, the power went out. It must have been. But, so, on this slide, what I wanted to make the point of mistakes that may occur in terms of how they construct the median. In order to
I think we're having some errors, some technical errors. I don't know. Then they're not talking they had lunch when we had break.
Because I'm sitting on week because we
You can't be on this class.
It's terrible.
Yeah, we have test on Thursday now, so we need to go.
Yeah, that's one thing.
Joma and you, you're going to be a set. Donald, do not misbehave. Alright, let's go into the. But I really wanted, how am I going to do this now? I really wanted Bermuda to hear the comment that I have and to be able to give their comments. Can we call them? Can we call Bermuda? We have to wait for them to call us back. Let's give them a few minutes. Let's give them a few minutes.
hello?
Wow, thank God you're back. Yeah.
Okay, I'm sorry. I don't know. Shall I start from the beginning or did you hear most of it?
I understand what you were saying. Don't start at the beginning because we might not stay for very long.
Oh, I'm sorry. Anyway, so what I was trying to say.
Yeah.
That's signing on this.
It's a little bit of low grade to end up being understand.
As long as Stacy not suffer.
Stacy, I would tell him. Stacy, I'll give you
Hello?
You're back.
Sorry, I don't know what's
going to stay with us.
You can't see, but.
The magic.
Oh, you guys are kidding. It's up.
Yeah.
Alright, so I probably just need to. They're calling back. Bamida calling. Bamida?
Yeah.
Alright, yes. Go ahead. Crystal, we can see you
Oh,
there.
yes. Okay, so if you can, Jeremy, if we go to the one previous to this.
Previous?
Yeah. So most students, they got confused that when they give the median coordinate, they solve for 15, but you have to use the horizontal, or I'm sorry, the vertical line to solve it. But you actually, when they ask for the median, it's actually you're taking it from the horizontal coordinate, so it actually wouldn't be the 15. You have to solve for this. I think it's 7 point. I can't see it clearly, but. You have to practice. Hello?
Hey, let's do it.
We're still here?
Yeah,
So,
it's just back on what's. Oh.
That's pretty much it. That's all that I was able to get to, so.
Alright. Alright, so I'm gonna go through the presentations.
Okay.
So Crystal, that was the first presentation, your presentation was the first presentation, or is the first, technically is the first presentation. Because what you did was basically added to that. So what I see missing from your presentation, Crystal, you mentioned some of the possible things, like I have written down here, you talk about students being unable to plot points, and you talk about vocabulary.
Okay.
Crystal, are you hearing? What was missing from you guys presenting was the fact that I did not see like the hyperlinks. I think I needed some links like that we could. Let me say this again. You know how sometimes you're relating now an error? We're unable to relate to that error because we can't see the question. So you needed a link or something where you could have that question, pull up the question, we could look at that question together so we can relate to what you're saying. Am I clear with that, everybody?
Yeah.
Yes.
Do you guys agree with me?
Yes.
Yes.
For me.
No.
And so we couldn't relate to the error, so you needed the hyperlinks. That's basically it. I still wasn't so comfortable in you demonstrating that why you think students make the errors. You wasn't thorough. Alright, so the next presentation, no. Do you want to add anything, anybody? Are you agreeing with what I'm saying or not agreeing? Okay. Not agreeing? Okay. Rosina and Arantos. So you gave that up there, Arantos and Rosina, which is not part of what you would be graded for. Even though I think it was a good application for practice. Are you following what I'm saying? It's not so if you look at the things, I sent you a list of things that you'll be graded for. But that wasn't on it. But I think it was a good application for practice. It's students to practice their algorithm, not a concept now, but their algorithm. I said, and I also think that the reason that you gave us students making these errors, I think it was vague. It wasn't specific to say, all right, when the students make X error, I believe it's because of da 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 da. It was like a general thing. So I don't even have it, but it was, for me, it was vague.
Okay.
Alright, and so I don't talk about the good things, I was talking about where I need improvement. But you guys have many good things, you were prepared and all of that. So, and also I said it was there because I didn't give examples. So sometimes we're talking and we're saying that, oh, I see that students make this error, da 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 da. You can say because if you look back and so and so and so. So you need to be referring to the things so we understand exactly what you're saying, why you made those deductions, why you draw these conclusions. That's important.
Okay.
The next presentation was, anybody anything? Anybody want to add anything?
I don't remember what the present was. I think the start was some like the error in IKEA.
Yeah.
And you know, I wasn't sure if like why IKEA, because to me it was about the matrix and I don't have a question that state that they must use a matrix method, but if the question says a matrix, must use a matrix method, and I can understand the criticism. But if it never said that, I don't say.
Yeah, I talked about that with I think I said something about it already.
Oh.
But
yeah.
You know, one
to me it was just algorithm and procedure. So.
Yeah.
Miss, can we have the class on display again, please?
The what?
Oh, they're looking for it.
The class. The class.
Okay, we look at the class. Okay.
Right there.
Okay,
Yeah,
so
right there is fine.
a very good thing that I noticed with Rosina's and Arancha's presentation that I must say, which was important, is that they were giving us a real life application of the matrix idea. So, you know, so that for me was important. I love that. I really like that. Really enjoyed that. Age, you know, we are moving on. Anybody wants to add anything? Okay. Adrian and Christina's presentation, I think was a very thorough presentation. What do you guys think? I think it was very thorough. Adrian, I have some things here. They were thorough. Adrian was ensuring that whatever ideas he was putting across, they were well detailed and well explained. I don't know if you guys realize that, but it was very good. I like that they talk about you know what, when you think of math, what comes to mind? So they were using that mistakes. The errors were because students were making the linkages. These are words that I pick out and write down. They weren't making the linkages. They weren't looking for relationships. They weren't looking for prerequisites. They talk about vocabulary like collinear, collinear and other things. But I think for me, I get that idea that they understand how math should be taught. All of that was sorry, I really like that. I didn't really, to be honest, I really didn't have any problems. I didn't see any major problems with that presentation. I don't know if any of you can pick out anything, but I really didn't see any major problems. I also see strong evidence of teamwork. They were working. You could see that they complemented each other in the sense that Adrian was able to explain his part. You know, they were able, Christina was able to explain her part. So that's what I saw in that presentation. I really don't see any major problems. But if you have anything to add, that would be a good idea. But I really didn't see any major problem with that presentation. Do you have anything to add, anybody?
Yeah.
Alright, so I have Casey as a Joma presentation. I think the presentation was creative, like in terms of how they started off with the reflection of that reflection, that mountain, wonderful, that thing was always reflecting. The mountain, I think, was good. So I think that the presentation was creative. We see evidence of teamwork. They were working together, so we saw that. They talk about the language of math, why it was so important. They talk about the jargon, the vocab, all of that is very important to the teaching and learning, especially what they were doing in transformation. That was very important idea to come out. But one problem I have with that, it's not a problem per se, but one area that I have a little bit of issue with is that I need some more examples. Like, you know, you're talking about something, give me more examples. So I didn't see enough. Yes. So when you're talking about vocab, alright, so what are the vocab that you're expecting teachers to use when they're talking to the students? So that was what was missing for me. But it was a fairly good presentation. Now I have Stacy, and anybody wants to add anything?
I have a question for you, but I'll ask it after you finish.
Now I have Stacy and Donald's presentation. Stacy wasn't here. I don't know if there was any teamwork. But what I like about this presentation, what was unique about this presentation, is that it was interactive. Don't you think? This presentation, only presentation that really gets us involved, which is something that I like. If you're doing a presentation, after 15 minutes we want to fall asleep if we're not trying to engage us a little bit. That was important for me. And so I guess why that presentation would stand out for me too is that whatever errors, so you know, that whatever thing that Donna would have missed, you guys would have said it. So technically, we helped him to get an A.
Thank you guys. I love you all.
So I'm just messing.
Hey.
So because when he was talking about, all right, these are the errors. He was asking, after he mentioned the ones that he saw, he was asking us, am I missing any other errors? So we get to discuss all of them. When he talk about his cause for these errors, why does this make these errors? What happened to what he was also doing was asking us, what do you think? So whatever they missed, we were able to share. So it was very interactive. That's what I like. To be honest, I don't really have any major. I don't have anything. I don't really have anything negative to say about that presentation yet. I'm just kidding. Crystal, you wanted to ask a question?
My idea, but then my classmates kind of answered it for me in terms of, and I guess maybe this is where I'm misunderstanding your instructions, because when I was reading the instructions, I thought we had to specifically just look at the errors that was discussed in the report, but we should have incorporated common errors that we see in the classroom. Is that what you're asking us to do?
Yes.
To incorporate both?
So
because what?
I'm
just looking at. Go ahead.
No, it's okay. I'll wait on you. I'm sorry.
No, I was just saying, I guess I'm a little confused because I thought we were supposed to expand on the errors that were outlined in the report.
Yes. Okay, that's fine. You were supposed to just look at the errors in the report. But if you want to incorporate the others, because if we're out there teaching, we know that there are other errors that students generally make. So that's for me, if you do that basic, just the errors that are on the report, you get a full mark. For me, an icing on the cake would be, okay, I also, as a teacher, I also noticed that. So it's not that you get an added grade for doing that. But it's good for, because when we think of a presentation, we're not thinking about a presentation just to get a grade alone. It's a learning activity.
Right.
So,
we want to know we just want to know how to improve. So we just, from what you said for everybody else, when I listened to you, I heard that, and I saw it when they were incorporating other experiences. I guess our focus was like, oh, we have to just stick to what was the common errors.
But if you do just that, for me, if you do just that, you get your full grade. Not a problem. You will get a full grade for that. There was no problem there for me, any at all. But for me, because this is more than just, because I don't want you to see a presentation as just an avenue, as an assessment only. It is a learning exercise. So even though we're doing that, an icing on the cake would be, all right, as a teacher, and I'm in the classroom, I observe this error and that error. So that's how I see it. So it's not that you get an added grade because I have a defined rubric to say once you have this, you'll get your grade. But it's a good discussion for a presentation because it is a learn. You should be learning from it. Okay. And Crystal, don't worry that you did poorly. You didn't do poorly. Trust me. None of you did poorly. None of you failed the presentation.
No, I just want to learn. I like to learn from, we're all students, right? So it says to learn from my classroom. Okay. We want to learn well, this is the last class we're going to have Miss McCarthy, so.
Yeah.
I didn't hear that.
No, I mean, this is the last course.
Oh, the last course. Right.
For future reference, when we have you next time.
Yeah, when you come
to Bermuda, we'll have you next time.
Alright, so I think that was it. Was there anything else? Did I miss anything?
How are we administrating the test on Thursday?
I think on Thursday I sent your test to Miss Mills, who is our program coordinator. So she sent an email to your program, to your coordinator.
She's actually out on vacation.
She's out on vacation.
She's out. Okay, give me a second.
So wait a minute, are we saying that last time? You have your email? The same with
I just knew I had to pick this up. I saw it.
But this one seems that it's me. This seems that
What are the two? What are the two? What are the B and C right in the key?
And these are the first one.
Or at least, I mean, I don't know.
Some got all of them different plans. And things. I mean, that's right.
All right, Bermuda.
Yes, ma'am.
If your coordinator is not here, do you know who we can talk to? Who else?
No. Unfortunately not. It's not funny, but no. Have a second.
Can you arrange us? We know that you're the class, that you're the group rep. You are the group rep. So can you?
You know what? When this is finished, we're gonna have a tour. When this is all done, we're gonna have a tour. A serious tour.
Okay, all right, no problem. But what I want you to do is this. I want you to find out who is next in line. What will happen? All right. And just please send me an email. All right, please find out. Christina, are you comfortable with what will happen on Thursday?
So we're gonna write the exam in here, right?
I didn't hear that.
We're writing the exam in here.
Yes, that's it. Adrian, are you comfortable about what should happen on Thursday?
If I'm clear about what's gonna happen on Thursday?
For your test, yeah. For your in-course test.
No, I wasn't aware that it was on Thursday, miss.
Are you serious?
No, miss, honestly, I wasn't aware. When you mentioned it, miss, I think you said a date to be announced.
Yeah, but it was announced last week. It was announced. Oh, you weren't?
Oh, remember I wasn't here last week, miss.
Yeah. I'm sorry.
I was absent.
I'm so sorry. But can you find out from your coordinator if everything is in place, please? That's for you and Christina. Can you find out and send me an email, please, today, so I can know what to do or where to go from here?
Okay, sure.
All right, so Orantos, so I'm expecting an email from Orantos, Christina, and Adrian.
Okay.
All right, so Thursday, you do the test for 2 hours until 11 o'clock, Jamaican time, please. Then you get your break, and then we need to go
again,
through
what
the
time?
text.
Jamaican time?
9 a.m. Jamaican time.
What? Give me the time again, miss.
For the test, from 9 until 11.
Okay.
And this is Jamaican time. Please don't be late for my test.
Who would do that? Jamaican to always late.
Miss, you want to tell us what to expect or anything like that?
No, I don't want to do that. That's question I
Miss, you really should know, miss, because we haven't done a test in so long. Seriously.
I'm gonna have testing time.
Right. You guys will be fine. Don't worry about it too much. You'll be fine.
We have math test anxiety.
You have math test anxiety. All right. I hear you. All right. So at 11 o'clock, so I need to say one more thing. So at 11 o'clock, you'll get a break, and then you come back. When you come back, we need to go through the text. I don't want to make you all anxious or anything like that. That's not the purpose. But Thursday will be the last class, and it's not about just getting an assessment. I don't believe in that alone. You have to get feedback. What did you do right? What did you do not so right? That is important, so you can learn from it.
What do we study tonight? What do we go over? We just come as we are? Are we well equipped?
Alright, let's talk about what we've been doing. Let's go through, just do an overview of what we've been doing for this course so far. We've been looking at errors, looking at different topics. That's what we've been looking at, don't it? Yes. We looked at different topics. That's how being done at this the CXC, at the CSEC and the CAVE levels. We look at picking up idea and concepts versus procedural. I'll talk about being able to recognize the idea behind a math concept or the idea behind a math topic or strand. So basically I can't test you on something that you haven't done. So that's what we did. We look at assessment, the different types of assessment. Did you remember that class? We look at the different types of assessment and why we need to use alternative assessment. We look at things like that. We look at the purpose of assessment. We looked at this, what else did we do? Come on, help me. I don't remember.
Yeah, young lady, you can't remember.
We looked at some of the, we looked at the CXC syllabus and we said, alright, these are the things that should have been here, like for example, the time that should be allocated for each topic. Alright.
So we looked at the syllabus,
so we look at the syllabus. So we also look at the math syllabus, the CXC, the syllabi. So we look at the CAVE and the CSEC. Oh, no, we never looked at it. Alright, so we look at that syllabus there. So we were supposed to look at that syllabus and to see if it is awesome, complete. How do we know that it's completed? Does it have all the elements that the syllabus should have? We look at an exam, we critique an exam. Is the exam being assessed? Is the objective aligned to the assessment? So we look at little things like that. So basically, that's a general overview of what we did.
Okay. All right.
Right, so good luck for Thursday, and I'll see you on Thursday. And please don't have much test no. Yes.
I have a question. Is this our last week of school or do we have next week? Thursday
the last class.
See? Okay.
So we won't see you after Thursday.
I hope not.
This morning.
Last semester you said we're not seeing you anymore.
Don't worry, I might come to St. Lucia one day.
Yeah, okay.
So, I mean, at the end of every semester, I keep saying, all right, I won't see you again, goodbye.
Yeah.
And then you'll see me again, so let's see, I don't know what will happen, but so I won't say that anymore. All right, so I'll see you on Thursday, and good luck.
All right.
Thank you, miss.
All right.
This is all That's why she could think of one day.
Easy.
I'm leaving. I need experts.
Am I missing anything? I'm just trying to cute. Look how I'm missing
She sent her mom.
Everybody was such that I was saying kind of and say that they crazy.
No, it's a happy birthday. And my mom was like, she's living, she's in bed. She's an early child.
Everybody.
Mom been like, mom said, I got her in 8 years. Oh yeah. Could she tell the sister to get the program? And my husband's a lot older than me. Okay. Because my age, you have primary school together. So, yeah. Every night.
Thank God. Thank God, Vanessa.
I don't know.
What you keep it?
Not there that moonshot.